This is a train built for climbing mountains. A thrilling, chilling roller coaster through the Swiss Alps, with twists and turns that would derail most other trains. And some hair-raising natural hazards, too. The Glacier Express is a world-class alpine ride, and I'm about to get a panoramic view. Using unique technology on the locomotive and amazing engineering along the route, it climbs over 16,000 feet. That's almost 5 kilometers high through the magnificent Swiss Alps. It carries hundreds of thousands of people every year and is one of the most famous trains on Earth. That's the majestic Matterhorn, the king of the Alps. And this is where my day begins, in the famous ski town of Zermatt, at the foot of the Matterhorn. This is a car-free town, just hikers and skiers, and a mighty train service. And it's because of towns like this that the Glacier Express was built. People had been coming up here for ages during the summers for the invigorating mountain air. But when skiing became popular about 100 years ago, getting tourists here in the winter was incredibly difficult. The Glacier Express was the solution. But first things first, the Glacier Express heads into a depot near the station for its daily morning maintenance check. Technical inspector Philibert Moser is a hard man to please, and no one's going anywhere until he says so.
De eerste taak mag u controle van onderbouw. Zahnräder, die Räder, die Achsen, die Verschraubungen, die hydraulischen Sachen, das kontrolliere ich alles an einem Tag.
A train that tackles steep mountains every day needs a secret weapon, and this is it, rack and pinion technology. The round cogwheel, or pinion, attached to the undercarriage of the locomotive, has teeth that slot into another set of teeth on a straight rack between the rails. On the steepest sections of the track, going up or down, the cogwheel will help to give the Glacier Express an amazing alpine advantage: steel traction. Philibert eyeballs the rest of the undercarriage and notices that some brake pads need replacing.
Also, wenn ich Kontrolle mache, sehe ich optisch, wenn der Klotz abgenutzt ist, muss ich den auswechseln. Und in 5 Minuten ist ein Bremsklotz gewechselt.
Once Philibert signs off on the brakes, cogwheel, and other components, they get a scrub down and go through a giant train wash. Shiny carriages and crystal clear windows will keep the tourists happy. Then it's hookup time. Carriages connect with the locomotive, and the Glacier Express rolls into the station for boarding.
Track 12, the train now arriving is the Glacier Express to Andermatt, Disentis Moster Cour St. Moritz. Departure at...
Engineer Odilo Polinger is the guy who gets to sit in the cab up front.
I'm the driver here, and it's a really nice job.
Odilo has a special relationship with this train. He's known it all his life.
So when I was a little boy, my parents' house was near the track, and I saw every train who passed the line. So it was a boy dream to become an engine driver.
We're leaving in less than 5 minutes. Yolanda Alini, the train conductor, does her final check of all the carriages and uses light signals to tell the engine driver the train is good to go.
When we prepare the train in the morning, we have as well a lighting information for the driver. And now everything is working good.
The catering crew gets to work before the trains even left the station. Alexandra runs the Glacier Express's kitchen, and her staff will need to whip up a gourmet lunch for as many as 210 passengers, working in a galley that can sometimes feel more like a carnival ride.
You know, you don't have much space, so you have to keep the balance, you know, like you have to also get used to it, and yeah, it's very challenging, yeah.
The train's crew is all set to tackle another journey. Me, I've never been to Switzerland before, and I'm really stoked. I can't wait to find out more about the train's ingenious technology that makes it possible to conquer its alpine route. Our journey sets off from here and follows a crooked line through the middle of the Swiss Alps, from west to east. But that's only half the story, because our 290-kilometer journey is also about going up and down. We'll travel up mountains 2,044 meters high and down into deep valleys, across 291 bridges and through 91 tunnels to arrive at our destination of St. Moritz.
Ladies and gentlemen, the Matterhorn-Gotthardbahn train crew welcomes you on board the Zermatt shuttle from Zermatt.
The Glacier Express has left the station.
Ich hoffe, op een lokaal.
Ja, hallo, das ist richtig. Die umfahren das Fahrzeug.
Ja, das ist gut, merci.
Jo.
I find myself in the middle of an amazing mix of nationalities. There's something kind of Swiss about that. 250,000 passengers a year come from all over the world to take this ride.
We're New Zealanders, so we do mountains.
So where are you guys from?
From Bangkok, Thailand.
We're from Lucerne, Switzerland.
We're from Ottawa, Canada.
And this United Nations vibe is Alexandra's favorite part of the job.
I can meet new people, so it's very international, like also the beautiful landscape.
It's a view that never gets old for Alexandra and her team.
No, because sometimes you don't have any time to look outside.
Up front in the locomotive, and only minutes into this trip, the train is already in a steep descent. And Odilo is about to make his first use of what makes this train so unique, the cogwheel.
There is the start of the cogwheel. And we're in.
The Glacier Express is a model of Swiss quality and design. The locomotive has 2 cogwheels, along with 4 normal drive motors. That means it can switch back and forth between the cogwheels and its steel wheels, same as the ones on other trains. It's all electric, using overhead power lines to provide enough horsepower to pull 200 tons up a mountainside.
When we go down to Brig, the gradient changes, and when the gradient is bigger than 7%, we need the cogwheel. Otherwise, we slide down the mountain. So the cogwheel helps us to put the train down. So now we are on the cogwheel.
I'm up in the observation carriage, taking in the striking scenery. With the Matterhorn peak at our backs, so far, it's all downhill.
It's really steep, yeah.
Engineer Odilo heads the train down into the Rhone Valley and never takes his eyes off the track. His reflexes and the emergency brake are all that stand between a rock on the track and a potential train wreck. But soon, we'll be battling terrain that's derailed even the meanest mountain train. I'm into the first hour of my alpine train ride through Switzerland on board the Glacier Express. Even though we're on a mountain railroad, it's been all downhill since Zermatt.
It's really steep, yeah.
We're losing about 1,000 meters in altitude in our first 90 minutes, on a track with a grade that would be unsafe for any normal train.
And after this we go down also 12.5%.
It will take us about 8 hours to cover these 290 kilometers, so I've got plenty of time to soak up the scenery. That's because even though the Glacier Express can travel up to 100 kilometers an hour, it rarely does. And with the cogwheel engaged, it can only go 40. No wonder it's called the slowest express train in the world. The cogwheel is what puts the Glacier Express in an exclusive niche market at the top end of the train manufacturing industry. This is the world-renowned Stadler Rail manufacturing plant in Bussnang, Switzerland. The carriages are custom-built here. Stadler specializes in mountaineering trains, deploying the most high-tech science and quality engineering in the industry. Not that rack and pinion technology is new.
Technology of cogwheel railways is more than 100 years old. So at that time we had great engineers who invented those systems, which is still valid nowadays.
Rolf Waldvogel is the team leader of the Bogies and Wheels department at Stadler Rail.
What has changed is a lot of materials are different now. They're stiffer, they're harder, so we have less wear on the parts, but the technique itself is the same.
In the bogie room at Stadler Rail, engineers make and maintain the bogies. A bogie is the truck or base of the train's carriages that houses the cogwheel and brakes, and Rolf is an expert on the cogwheel design.
Well, we are standing in front of a gearbox which drives a cogwheel train. We've got a mechanical gearbox which is driven by an electromotor of roughly 300 kilowatts, or in other words, some 450 horsepower, driving one axle. Or in other words, it's driving not only the axle or the wheels, it is also driving the cogwheel here.
Most trains are simply steel wheels on a steel track for the smoothest possible glide, sometimes called an adhesion locomotive. But that means they work best on a near flat surface, up to a 3% grade, or a slope of about 25 meters per kilometer.
From a flat railway line, which it would be about that, we have maybe 4% is like that, 6-7%, and then roughly in this area we need the cogwheel.
The rack in a rack and pinion system is the fixed line of steel teeth running down the center of the train track between the two rails. When the turning cogwheel's teeth lock into the stationary rack's teeth, there's no more slipping and sliding, even on a slope with 12 or more degrees gradient.
Now we come to the end of the cogwheel. And I can drive faster.
We've made it down to the first low point on our route, 658 meters above sea level. This is the Rhone Valley. Coming up soon is Brig, a 13th century village that speaks mostly German. From here, we'll need to gain 1,400 meters in altitude.
So the next cogwheel will start shortly.
It's going to be an uphill battle. And once again, only the cogwheel makes it possible. I'm about to experience my first really steep climb. As the Glacier Express heads uphill, its locomotive is fighting gravity with 8 cars in tow.
They've got 185 tons, the whole train together.
The heavier the load, the more energy it takes, and the more costly it gets. Which is why, under Rolf Waldvogel's direction,
here we are standing in front of a roof for a lightweight car body.
The folks back at Stadler Rail in Busnang are perfecting ways of keeping the Glacier Express carriages as lightweight as possible.
You want to have a light train to go up there because consumption of energy. Rather, you choose a light train than one made from steel, which is really heavy. And we're using here aluminium alloy in order to reduce the weight. Now, some 98% of our car bodies we produce are made from this material.
We're slowly edging up into snow country.
Dag middenand, hier de vaarkaarten bitte. De BS s'il vous plaît, your ticket please. Dank u vielmals. Kaarten zijn perfect.
Now this is starting to look like the classic Switzerland of my imagination. The Swiss Alps are a magnet for winter tourists. A top holiday destination ever since downhill skiing became a popular sport in the early 1900s. But getting here was a big challenge, until the Glacier Express got rolling on June 25th, 1930. Since then, it's transported passengers safely and in style. But sometimes even Swiss engineering is no match for nature's fury.
Because there is a new track, there was a mountain slide on the other side, so the old track is away.
In 2014, another landslide derailed a Glacier Express train. 3 carriages plunged over the edge. 1 passenger died and 10 were injured. But the biggest danger in the Alps has always been at the higher altitudes, getting buried in snow. And we're about to enter the notorious avalanche zone, so dangerous that it kept the Glacier Express from risking winter service for its first 50 years. The mighty Glacier Express is edging up towards the highest point of its route through the Swiss Alps. We've regained the 1,000 meters in altitude that we lost when we first left Zermatt. But we've got hundreds of meters more to climb. And now we're surrounded by serious snow and ice. This is avalanche country. The only way to stay safe is to take cover. And on this route, that means snow sheds and tunnels. Lots of tunnels. So this is really exciting. We're a couple hours into the journey and we're about to hit one of the most famous spots on the route. It's called the Furka Tunnel. It's 9.5 miles or almost 15 kilometers long. It cost $300 million to build and took a really long time, but it's incredibly important because this tunnel is what allows the Glacier Express to run in the winter. Otherwise, we'd be going over the mountain and through a very avalanche-prone area. Here we go. Now we're in the Furka Tunnel, and we're gonna be here for quite a while because it's really, really long. Meanwhile, even in this tunnel, we're still climbing hundreds of meters. When we finally come out the other end, hey, I could use some sunglasses. We're just a minute away from one of the most remarkable parts of the journey and easily the most challenging point on the route. And you can tell from all the snow how high up we are. This is the highest we're gonna get. 2,044 meters above sea level. It's the Oberalp Pass, which means, you guessed it, the Oberalps Pass. We had a rapid ascent of 1,000 meters, and then we hit that highest point on the trip. And now we're engaging in a very rapid descent. This is one of the only trains on Earth that could make this journey. Look at that. We're heading back downhill again to the town of Decentis. After that stop, we'll keep going down into the lowest point on our route. and the awesome scenery of the Rhine Gorge. The train has to work just as hard on a steep descent as when it's climbing. Not only with the cogwheel, but with the brakes. The worst thing any engineer can imagine is a brake failure. That's why here at the Lundquart maintenance yards near the Swiss-Austrian border, every new Glacier Express locomotive gets extensive brake testing.
So now you can see how the brake force is increasing. This is the pressure and this is the kilonewton. So we have 9.5 kilonewton in brake force by a pressure of 1.93 bar.
David Vigratz is an expert on operational testing of brakes for trains like the Glacier Express.
If you have a train that is not braking, well, anything can happen, okay? So the brakes are the first thing that we're testing.
David oversees a series of brake tests on this brand new Stadler Rail locomotive. It's a highly controlled and computerized process.
We do brake tests with different speeds and always pulling the emergency brake. And then we check out the brake distance and the curve of the deceleration.
This time, David notices that something's up.
It's called 1.5. This deceleration.
On one coach, the anti-skid brake system has kicked in briefly. It's supposed to help keep the wheels from skidding when braking on a slippery surface.
Yeah, there's one curve here, and that makes no sense because the rest of the train is not skidding at all, so there must be something wrong at this coach that we have to check.
David repeats the test at 100 kilometers an hour. That's as fast as the Glacier Express is ever likely to go.
This time everything is just fine. No gliding, no anti-brake system, the deceleration, everything is okay.
By the time David's done checking out these brakes, they'll be a model of Swiss precision. Back on the Glacier Express, next to the locomotive driver, no one is more aware of the brakes than Alexandra and her kitchen staff. For them, steady brakes are critical, especially during moments like these, serving hot drinks or wielding a sharp knife. Now that we're losing altitude again, I chat up some of my fellow travelers about how they like the trip so far.
We thought we did great mountains, but coming here, they're astounding, really.
Yeah, we were just struck by the beauty of this country. It's quite remarkable.
What's been your favorite part, Les?
I think when we hit the glacier field or whatever it was, and just how bright it was.
But nobody appreciates that top of the Alps view like the couple I meet from Thailand, who found the mountaintop a moving experience.
Was that you who cried?
No, actually he.
He cried and he's saying it's someone else.
Yeah, because it's me, yeah.
That's okay, I kind of welled up too.
We're entering the town of Disentis, roughly the halfway point in our journey. This is more than a pit stop. This is where we swap out our cogwheel locomotive for a standard engine. The Glacier Express is co-owned and operated by two separate companies. They use different locomotives because the railroad is designed differently from Disentis onward. I'm watching the cogwheel locomotive that got me safely through the mountains this far roll away. We're about to tackle the second half of this mountainous train journey using a completely different technology. After gliding down into the town of Disentis, the midpoint on the Glacier Express's journey, It's time for a big change-up. The rack and pinion locomotive that got us this far has been unhooked, and a standard locomotive, sometimes called an adhesion locomotive, is hooked up in its place. This engine will be heading into mountains as steep as the ones behind us, but it will not be able to climb those tough 12% grades. From here on, the track has been designed differently, so it never exceeds 4%. I'm about to find out that there's more than one way for a train to conquer the Alps. John Capriz is an engineer on the Glacier Express. But he's more than that. He's also a local train historian who put himself in the shoes of the original surveyors who designed this half of the track a century ago. They studied the landscape and figured out where and how to lay the rails to keep the grade under 4%, no matter how steep the mountains. John joins me on board and reveals how they did it, starting with something called an open loop.
The open loop is built to gain altitude because the valley is steeper than the train can climb. So there is this open field that is wide enough for the train to go one way, then around in a short tunnel, turn 180 degrees, go back a little higher, the other way, turn a second time, you'll be on your original direction, but much higher up.
Open loops of track that snake back and forth as they climb or descend a slope might be 3 times the length of a direct route you could take if you had a cogwheel.
This is not easy.
So it's doubling back on itself, but
Yes.
it keeps gaining altitude with each different pass.
Yes, it's a very ingenious way of gaining altitude without spending too much money on tunnels.
Taking us on these open loops is a new engineer. Before becoming a driver on this eastern part of the Glacier Express route, Oscar Schwartz was a commercial airline pilot for 17 years. When faced with a job relocation to Asia, he opted for a career change instead.
Since my heart is really here, I love the mountains, I love this area, I decided, no, I don't want to go to Asia. And so I got the chance to change and start driving a train.
Oscar's switch from planes to trains brought new and surprising challenges.
In the airplane, you have high peaks, like a takeoff and a landing. And afterwards, during the cruise, the pilot has more relaxing time during the day than being a train driver. There you're always busy, you have always to do something. I cannot just lean back and enjoy.
That's because enjoyment is reserved for the passengers, topped up with a hearty lunch. And together with the high-end service, I get a great view of the lowest point on the route, only about 600 meters above sea level. It was formed by landslides that happened during the last ice age.
So this is really cool. The massive cliff faces all around us are actually the walls of the Rhine Gorge. We're in the middle of the gorge right now. That's the Rhine River, and this area is referred to as the Grand Canyon of Switzerland. And you can see why, it's absolutely beautiful.
The trouble is, here we are in a deep gorge, and we have to climb about 1,200 meters to get out of it, or we'll never reach St. Moritz. But how? Up ahead, it will be impossible to make giant open loops back and forth across mountainsides.
Higher up, the valley is so rocky and so narrow and so dangerous because of avalanches that you can't loop around in the open.
How avalanche prone is this area?
Very dangerous. This is an avalanche run across the valley.
Here?
Right over there. You see this area? The avalanches come down there every spring. And the line could have been built there, of course. It's open meadow. It would have been cheaper to build, but it would have been destroyed every spring.
Right.
Tunnels can protect the train from landslides and avalanches, but it turns out tunnels can also help the train gain or lose altitude. They're called spiral tunnels.
You have to turn inside the tunnel like a corkscrew. You make a 360-degree turn inside the mountains and exit up there.
The train comes out directly above the spot where it entered, only higher up.
So we're about to go into the mountain, we'll do some spirals, and we'll come out up there. Here we go.
You come out more or less exactly above where you entered, just a few meters higher up. So it's the last resort if you have no space and you absolutely need to gain altitude to build 1, 2, or even 3 spiral tunnels, as has happened here.
And so when we've gone through all 3 of these spiral tunnels, how much elevation will we have gained?
Well, we'll be up at almost 1,800 meters of altitude.
Wow.
All this twisting and turning is made easier because the distance between the wheels on the Glacier Express is so narrow, only 1 meter wide. That's almost 1/3 narrower than on ordinary passenger trains. This narrow gauge is custom designed for tighter turns in loops and spirals, and smaller tunnel dimensions. What I find cool is how often this mountain climbing train avoids traveling into and out of deep gorges by taking a bridge between 2 high cliffs. They're called viaducts. There are almost 300 of them along the Glacier Express route, and the most amazing one on the whole line is coming up now.
That is the Landwasser Viaduct. It's the most famous of the hundreds of viaducts on the Glacier Express route. And it is awe-inspiring. Wow.
I wonder what it's like driving the train over it day after day.
Yeah, it's a little bit strange because you have the impression there is nothing and it's very narrow, so it's a little bit something you have to get used to it.
It is a masterpiece of engineering. Built in 1901, it's 65 meters high, 136 meters long, and made entirely from local stone. It's still standing after all these years, and John just can't resist showing it off.
It's like a church spire. It's very, very tall and narrow. It is an icon. There are millions of photographs showing it, and it has something that has developed its own life because everybody looks at it.
And at the base of the viaduct, a UNESCO World Heritage Site plaque. John headed up the committee that lobbied hard for the designation. He was inspired by the profound connection that the original builders had with the Swiss landscape.
So the engineers had to know very much about floods, about avalanches, and they had to know a lot about nature to build this line as safe as it is.
Safety was a priority for this railway right from the beginning. But there is one growing concern that faces the Glacier Express today, and we're about to drive right into it. We're heading toward the oldest tunnel on our journey, with a disturbing reminder that just because it's carved in stone doesn't mean it lasts forever. We're nearing the last hour of our Swiss Alps train trek and approaching the second longest tunnel on the Glacier Express line.
So now we go through the Albula tunnel. It's 5 kilometers about long.
The Albula tunnel was the first tunnel ever built on the line. It took 5 years to complete and opened to train traffic in 1903. But unlike other tunnels along this route, it's now really showing its age. It's midnight, when the trains aren't running, and the safest time for structural engineer Gilbert Zimmerman to closely inspect what it is that keeps him awake at night.
One problem is here the cement. It's so old, it's not stable enough to keep the bricks together. The other problem is that the water, which we can hear right now, builds up a pressure behind the rock and the wall. This pressure might push the wall into the tunnel and will cover the tracks.
The mountains of the Swiss Alps aren't all made of the same stuff. Some of the rock the Albula Tunnel cuts through is limestone, and limestone is naturally soft and layered, and the layers can be porous. Combine that with a high glacial runoff through the cracks of every snow-capped mountain, and you've got very leaky walls. That's why now, after 112 years, the walls of the tunnel are crumbling. The water seeping through the rock is getting out of hand, sometimes gushing up to 300 liters a second. There's also a glacial lake on top of the mountain above the tunnel. That means more water seeping downward and huge pressure on old infrastructure.
It could be a catastrophe when this water pressure is too high.
The tunnel needs its own ditches and pumping system, working 24/7 to divert the overflow and keep the tunnel from flooding. The safest solution is to build a better tunnel, and Gilbert is the lead engineer.
We are standing in front of the new Albula Tunnel 2, which we started building last year in August.
The construction of the new Albula Tunnel has begun, right beside and running parallel to the old one. It's an ambitious €345 million project.
As you see here, we are some meters already inside. Today we are about 200 meters in 84.
Like most of the 91 tunnels along the Glacier Express route, the old Albula Tunnel was dug with simple tools and backbreaking labor. It has the most tragic history in the entire line's construction, with over 2,000 accidents and a horrific cave-in and flood that caused 16 railway workers' deaths. But the geology of the mountain is better understood today, and Gilbert's crew has got a brilliant new strategy. In this vault-like setting, workers are jamming 60-meter pipes into the rock face in the shape of an arc. The pipes are filled with salt water, then frozen slowly to a very low temperature. The pipes get so cold that the surrounding rock also freezes, creating a solid arch. Crews can then excavate inside that icy canopy to build the new tunnel. The canopy is temporary, and after a section of tunnel is safely hollowed out, the walls are supported and sealed with concrete, and the ice eventually melts.
We solved the problem on a basic idea. In this way, we are going through like in a shell.
The rock freezing technique is slow. They inch along, freezing large sections at a time over 4 months before excavating them.
The next step will be we open the rock again with the heavy machines.
And what a difference a century makes. No hand tools here, just very large, incredibly wicked machinery instead.
Before we had 1,300 people each day on this work site. Today we have 5 people at the front work, and on the whole work site about 8 people.
The new tunnel will take 8 years to complete. This new excavating method is much safer, but it's also slower, especially going through limestone.
When the rock is harder, we can open up to 9 meters a day. But this is a really bad rock, so that's why we have only 1 meter or 2 meters.
And Gilbert knows that every meter excavated brings his crew closer to the most dangerous part of the mountain. It's an old fault line. It's unstable, and there's no way around it. I'm nearing the end of my incredible Glacier Express train journey through the Swiss Alps. This is the Albula Tunnel, the oldest train tunnel on the Glacier Express route, and it's being replaced. But Foreman Gilbert Zimmerman knows that the construction of a new tunnel comes with an extraordinary danger. Running through the center of the mountain, there's a fault zone of unstable rubble. It's the scar of an ancient earthquake.
So it's like crushed rock, crushed into little pieces like this, filled with water, sand, and mud.
It was discovered the hard way during the construction of the first tunnel, when the walls collapsed.
I was completely flooded with mud. Stones like this, working was stopped for over a year.
There's no way for Gilbert to avoid this fault zone. They'll have to dig through it. History's proven how risky that is.
The risk that we have the same accident as 100 years ago. This area will be flooded and the whole water system above the surface will collapse. Maybe we could empty the lake, which is right now above us.
But their ingenious rock freezing technique promises safer tunneling for workers, and someday a safer tunnel for trains and passengers.
We also have much more security and safety in the new tunnel. The old tunnel we converted into a security tunnel after we have the new tunnel in operation mode. Between these both tunnels we have 12 escape routes which people can escape in case of an accident with a train.
All of this Albula Tunnel drama is happening right on the doorstep of the nearby mountain town of Preda. So protecting the environment is critical. But the cleanup is no small job. They've got to get rid of all of that excavated rock that's coming out of the new tunnel. 250,000 cubic meters of rubble. Crushed rock is removed on massive conveyor belts, a whole network of them running through the system like big yellow drainage pipes and carrying it off. That means no noisy dump trucks and minimal damage to the landscape. The crushed rock is converted to concrete and used to reinforce the tunnel walls. And the runoff water is purified and returned to nearby streams. For now, the old Albula Tunnel remains in use, constantly monitored and repaired, until the new tunnel is completed in 2023.
I have to wait now till the other train from the other side enters the station, and then I will get the green signal. Now it's really open.
Finally, out on the far side of the Albula Tunnel, as the Glacier Express approaches its final destination, St. Moritz. I'm thinking, sure, this might be one of the most exclusive holiday destinations in the world, but the journey getting here is an exhilarating end in itself. From the mighty Matterhorn to the Rhone Valley, from the Furka Tunnel to the Oberalp Pass, the Rhine Gorge and the Landwasser Viaduct. Wow. I can't believe how much spectacular geography this train fits into one 8-hour shift. If there's anyone I've met who really loves this train, it's John. When he was asked by the UNESCO people to put together a historical record of the line, he walked the entire eastern half, from Descentis to St. Moritz, imagining what it was like to lay those tracks.
And I walked through all of those tracks, over and under all these bridges.
A labor of love that convinced UNESCO to grant World Heritage status.
Well, I can say that I think this is one of the high points of my life.
And riding the Glacier Express is a high point of my life, too, in more ways than one. And here's St. Moritz, the birthplace of downhill skiing and the end of the line.
Wow, what a spectacular journey. I've got a whole new appreciation for Swiss engineering, all of the challenges that had to be overcome to create this route in the first place. And I can see why people come from all over the world to take this journey. What a ride.
the bullet train, Japan's high-speed legend.
There's nothing else like it in the world.
The Shinkansen powers the country's economy and thrills fans at every stop.
I love the Shinkansen.
But tough terrain, bad weather, and earthquakes are constant threats.
That was one of the scariest memories.
Keeping it fast, efficient, and safe is a challenge. I'm here to learn more about the groundbreaking and sometimes secret science that makes it all possible, and that puts the bullet train at the top of every rail fan's bucket list. This is Tokyo Station, one of the busiest transportation hubs in the world. Every day, more than 1 million passengers come and go here.
If I didn't have the Shinkansen, I couldn't do my job.
Commuters depend on the Shinkansen's speed. So does Japan's economy. It moves at 3 times the speed of most passenger trains, zipping along at 285 kilometers per hour. In congested cities, cars don't make sense. With 33 million people, Greater Tokyo is the most populated urban space on Earth. No wonder life here revolves around this station.
Hey, Daddy.
Nice to meet you.
Good to meet you. Hajimemashite.
I'm lucky to connect with Ryo Mineta, a cultural interpreter for foreign students. But on this journey, he'll be my guide.
All right.
All right, sir, can you show me how to buy some tickets here?
So first, reserve seats. We can sit together.
Let's roll.
Ryo and I are taking the Tokaido Shinkansen route, run by Japan's Central Railway. The original line built in 1964 for the world's first high-speed train. It took great ingenuity and innovation to build a rail system in an earthquake zone, on top of tectonic plates that are constantly shifting. We'll be traveling 500 kilometers from Tokyo to Osaka, making pit stops along the way to uncover the secrets of the world's finest high-speed train. But first, Ryo wants to show me something.
It'll seem like...
If you're taking a Shinkansen, you have to have an ekiben for sure.
Okay, so walk me through it. What do you?
Ekiben, literally translated, means rail station takeout. And it's a ritual on Japanese trains.
Do you like fish? They have sushi. Hai, onegaishimasu.
These boxed meals make lunch on the train fun and efficient.
Hai, so we have to eat before.
We got food for the train.
Yep.
The vending machines are everywhere in Japan. It's incredible.
Even our choice of drinks, available instantly, hot or cold.
Here we go.
Oh, yes.
Everything's about speed, efficiency, and punctuality. The train's cleaning crew doesn't have time for a single misstep. Teams of 55 have 8 minutes to clean the cars. As the clock ticks down, all 1,300 seats are reversed for the new direction of travel, wiped down, and covered.
There's no room for error to be late with this because the trains leave on time and they've got to get the job done. It's an incredibly quick turnaround.
We have to clean in a very short time, so everyone has to be very efficient.
While the cleaners race against the clock, we get to meet our driver, Ryosuke Kumazawa.
How does it feel for you as an operator to get to drive this train?
The Shinkansen is everyone's favorite.
I'm driving it using my own skills, and I really enjoy it.
He drives an average of 1,000 kilometers in a 6-hour shift.
It's challenging. There's a lot to learn, and a lot to think about.
So the Shinkansen is here. Is this the one you're actually going to be operating for our journey?
Hi.
Oh, okay, perfect. Well, I'll let you go do your job. Arigato gozaimasu. Thank you very much. Thank you. He's got to go get on the train. That's the one we're going to be on.
The N700A is the most high-tech bullet train yet. 16 cars can carry more than 1,300 passengers. It spans 400 meters in length. It's electric. 25,000 volts travel directly from overhead wires to a motor on each wheel set, making it effectively 128-wheel drive. At each end, there's a driver's cabin, so the train can travel in either direction without reversing. By car, the trip from Tokyo to Osaka would take over 6 hours. By bullet train, it's just 2 hours and 22 minutes. On Japanese trains, politeness is important, so Ryo and I will be speaking softly so we don't disturb anyone. Our driver, Ryosuke, hits the throttle. It takes about 120 seconds for the Shinkansen to reach a top speed of 285 kilometers per hour.
We're really going at an incredible speed now. And I feel fine, like it's a very comfortable ride, isn't it? Here.
One of the reasons the train is so fast is its sleek design and light weight. The aluminum body is just half the weight of a conventional passenger train. It also has its own dedicated track. No sharing with slower trains.
I've learned a lot about the sense of speed, how it feels physically.
Luckily, that speed comes with more control. The motor on every wheel helps grip the track.
Really fast.
With dozens of high-speed trains on the same track, they must stay at least a kilometer apart to avoid running into each other. In Tokyo, a team of highly trained technicians make sure everyone follows the rules.
The General Control Center is the nerve center of the Tokaido Shinkansen.
Data collected from sensors along the track give a snapshot of the speed and location of every train at all times. The system, called automatic train control, is a high-tech wonder.
The automatic train control, or ATC, tells each driver how fast to go depending on where other trains are on the track. If the Shinkansen exceeds this speed, the ATC will automatically activate the brakes, so the train slows down. This is how we make sure there are no collisions.
Using these high-tech tracking tools to keep an eye on the entire system is important work. But these guys really earn their pay when something out of the ordinary happens.
We have systems in place for emergencies, including sensors to detect earthquakes, so we can be alerted as soon as one begins.
Earthquakes are a serious threat to Japan. They strike more than 1,000 times a year. Knowing how to respond is a matter of life and death.
Another bullet train is whipping by.
Japan's bullet train has the world's finest safety record. It's never had one operational accident causing death. Not even during the country's most devastating earthquakes. I've never been in a major earthquake, but my guide Ryo is going to show me what it feels like.
All right, well, let's go in. This is where people get ready, basically, in terms of being prepared for an earthquake.
Citizens are encouraged to visit the earthquake center regularly to keep their survival skills sharp.
Konnichiwa. Arigato.
お読みいただきましたら最後に次へをタッチお願いします。ではすぐに丸か×かが出てきますので確認しましたら次へを押します。
Luckily, they've given me a handy tablet that explains everything in English.
ではそのままタブレットの画面を元の形
So it's telling us that there's been an earthquake and we have to survive for 3 days, 72 hours, because that's how long it's going to take the authorities and the emergency response to get there and get everything sorted.
下のマークを頼りに進んでください。また一部演出用のものが
Now we head into a simulated earthquake.
Whoa. Whoa. Oh! Here we go. Okay. Whoa. Whoa. Oh, wow. They've tried to simulate, basically, it looks like a city block here.
It looks terrifying.
All sorts of rubble. Look at the street lights.
Oh, even the traffic light is down.
Even though it's a simulation, it sure feels eerie.
Someone is calling. Like, help me.
That's a big issue with earthquake, right? So
Yeah.
Fires?
After earthquake, there's always fire going on, so...
Even more damage.
Right.
Wow. Where were you in the 2011 earthquake when it struck?
I was in Tokyo and I was actually eating at a cafe. Usually earthquakes last, for less than a minute.
How long did this one shake you for?
Like longer than 2 minutes, I think. I was getting kind of nervous.
Did it get stronger as it went on?
Yeah, it kept getting stronger. So the waitress actually came up, talked to me, and then said, "You need to evacuate. Get out here."
Yeah.
Scary memory,
Imagine if you were on a high-speed train when an earthquake hit. The futuristic brains behind the Tokaido Shinkansen have given it a lot of thought. They monitor sensors along the rail line that detect the earliest threat of an earthquake.
We have 21 detection points along the Tokaido Shinkansen line to identify the primary wave of an earthquake. And if it affects the Tokaido Shinkansen, it gives us an alarm.
The alarm alerts the General Control Center that power is being cut to the trains. If they're in the affected area, they'll be stopped before the earthquake hits. To keep trains stable, the Tokaido Shinkansen took even more steps. Interior guardrails were installed along the track to keep it from derailing. For more severe movement, stoppers under each car catch to keep it upright. In March 2011, the system got a big test. Underground sensors picked up the first tremors of a massive quake. Its magnitude was 9.0. It lasted 6 minutes. 20,000 people died. And it cost the country billions. All 50 trains traveling along the Tokaido Shinkansen line were in the earthquake zone. Remarkably, the trains were stopped a full 10 seconds before the earthquake hit. The guardrails and stoppers worked perfectly.
During the 2011 earthquake, not a single train of the Tokaido Shinkansen derailed.
No other high-speed rail system in the world can beat the Shinkansen's perfect safety record. It's something to be proud of, but the bosses know it doesn't come easy.
Our top priority is safety, so we feel a heavy responsibility.
Shinkansen employees do a lot of this, pointing and calling. It confirms that they're doing a task and doing it right.
Using our eye, finger, and voice. With all three things working together, we can make sure the train is operating safely.
A study by a Japanese research institute showed that human error drops by 85% when the body and mind work together. Our next stop, a one-of-a-kind workshop, where we'll see how Central Japan Railway keeps the Shinkansen in top form. What would happen if you missed something? We're 1 hour southwest of Tokyo, traveling along the original line of the world's first high-speed train.
So this is like vegetable tempura?
This is eel tempura.
This is eel tempura. Oh, it's really good. That's excellent. That's eel tempura. Yeah. I love it.
We're discovering a lot about the high-tech wonders of this train. And now we're going to have a unique behind-the-scenes look at how it's kept in tip-top condition. Next stop, Hamamatsu.
So here I am in Hamamatsu, and this train is going in for servicing at the Hamamatsu repair station. This is a rare sight to see a Shinkansen actually going through a crossing because this is the only one on the line.
Every 3 years, or as soon as it's run 1.2 million kilometers, each bullet train undergoes a complete servicing.
Nice to meet you. My name is...
And that's under the direction of General Manager Masahiko Tanaka.
Hi.
We separate a train into individual cars and take each apart, breaking down body, carriage, and other parts. After we thoroughly inspect every piece one by one, we reassemble the train.
The first job is checking the condition of the hard-working steel wheels.
We remove the wheels from the Shinkansen, and we check if there's no damage or scratches on the wheels using ultrasonic waves.
Tiny cracks under stress can grow. If they break the wheel apart at high speed, disaster. A single crack in one wheel of a German high-speed train caused this crash in 1998. 101 people were killed. Finding cracks, especially if they're out of sight, is a huge task. To detect anything beneath the surface, they use ultrasonic technology. After looking for cracks, the technicians need to inspect the wheels to see if they're still in good shape after so much high-speed travel. If all 128 wheels aren't precisely aligned, their unevenness creates vibrations that can increase to throw the train off the track. Every wheel must have the same dimension down to the 100th of a millimeter. Anyone who says don't sweat the small stuff obviously isn't working here. Now the wheels have been checked, they're paired up with the bogie frames that carry the all-important disc brakes. Every brake has to be carefully positioned to clamp against the wheel at the exact right spot. If an earthquake hits, these brakes are lifesavers. So these technicians have to get it right. For a train that's on the cutting edge of automation, it's a lot of old-fashioned, hands-on work for the 1,300 technicians. The pressure on every technician is huge.
Since the Shinkansen runs at a very high speed, if some nuts and bolts loosen and detach, it can lead to a devastating accident.
To stay sharp and focused, the technicians use the same technique we've seen elsewhere, pointing and calling out a checklist.
Using our eye, finger, and ear, we make sure everything is properly tightened. This is very important for the safety of the Shinkansen.
In another building, we get a rare glimpse of the workroom where the Shinkansen's electronics are serviced.
This equipment is what powers the Shinkansen. The maximum speed is so high that the train needs special control systems.
It converts electrical current from the overhead wires quickly and steadily to the motors. But I'm not going to find out a whole lot more than that.
Can we get a little closer? Can we shoot it closer?
Sorry,
No?
No, you cannot get closer.
No.
We have a lot of confidential technology here. We would appreciate it if you keep some distance.
Hi.
It takes about 2 weeks to completely overhaul each train and put it back on the rails.
The reason I love this job is that I feel a responsibility to the passengers to move safely on the Shinkansen.
I feel lucky to get a peek into how Japan's Central Railway keeps its trains operating at 100%, and its safety record as clean as the day it began. The concept of a bullet train took shape after World War II. Japan's economy was in ruins. Its leaders hoped that a high-speed train could link the country and help fast-track economic growth. The actual design came from engineers who developed kamikaze planes for World War II. They wanted to build trains to feel like an airplane. When it opened in 1964, the rail line did help kickstart the economy by transporting people to work in the cities, making Japan an international powerhouse. Next, I'm hitching a ride on the most special bullet train of all. It doesn't carry passengers, but it attracts a crowd wherever it goes.
Do you ever get tired of taking your Shinkansen?
Never.
No.
It's just so beautiful.
Yeah.
Japan has a devoted rail fan culture. Even miniature model trains attract crowds at the Railway Museum.
This model train diorama is fantastic because it gives us a snapshot of basically the entire Tokaido line. We've got Tokyo down at this end, trains going everywhere, Mount Fuji, Hamamatsu, including the massive Shinkansen workshop there, Nagoya, and at the end, Osaka. The level of detail and precision is really, really cool.
The diorama mimics a 24-hour day every 15 minutes, fading gradually from light to darkness and back again. What do you guys think of the Shinkansen? Why do you like it?
Speed.
It's unanimous. Speed is why they love their Shinkansen. For die-hard fans, this old train station, wedged between tracks, has been turned into a cafe. We've got trains going by us on either side here in this cafe, so is this the coolest place you've ever had a cup of coffee as a rail fan?
Yeah, this is a pretty cool spot. Although it's a pity that...
Alex Sims is such an enthusiast, he'll come all the way from Australia to see his favorite train in action. So you still get a rush out of the Shinkansen?
Oh, yeah. I like to take videos. Some people like to go and measure trains.
There's one now.
Yeah, or you can get lists where you can tick them off. So you say, oh, I've seen that one, and I've seen that one. The new...
Seems like the Shinkansen experience never gets old for Alex.
Seeing all the signs, hearing all the station music and announcements, the vibration of the platforms as the train moves, maybe on the deck below or above. And so it's that sort of whole of body vibration, sound, visual, bright lights, and then you get on your train.
Rail fans of this icon of Japanese design are common at every station, waiting to get the perfect shot of an engineering marvel.
It's not too bad.
Yeah.
It's my day off, so I brought my son to see this special train.
Families are crowding onto this platform today because the next train is a huge hit with the kids.
We came here to see Dr. Yellow. It's not something you can see every day.
Here it comes. Dr. Yellow only makes an appearance every 10 days. It travels the same route as the Tokaido Shinkansen, but it doesn't carry passengers. Its job is to inspect the tracks and overhead electrical system. That's great. Well, let's go over. I'm being escorted by a Japan Rail employee to make sure I don't push any buttons or turn any knobs, because inside this train is a hive of electronics. A crew of 7 technicians look for flaws along every inch of track and overhead wire. It's amazing. Mikihito Kobayashi oversees the track team. How is it that we can be going this fast and we're checking the track as we're going almost 300 kilometers an hour?
Sophisticated sensors mounted under the train read data from lasers hitting the tracks. If there's something wrong, we report it to the General Control Center in Tokyo, and it gets fixed.
It can detect flaws in the tracks as small as the nib of a pen. Above the tracks, it monitors the wires of the catenary system that supply 25,000 volts of electricity to the train. So it looks like I'm in a captain's chair, but actually this is an inspector's chair and is checking out the catenary system. And decades ago, it was the person who sat here who did the bulk of that inspection, but these days, most of the work is done by this camera. These technicians get the camera footage sent live to their screens. It's up to them to look out for defects that could potentially cause a power failure.
We need to check the wires for abrasion. because excessive abrasion causes wires to break and can stop the Shinkansen from running.
Any issues are reported immediately and fixed. No wonder Dr. Yellow has superhero status.
So many people love it. There is even an urban legend that if you see Dr. Yellow, you'll live a happy life. And that makes us happy too.
Dr. Yellow's day is done. But the work's not over. From midnight to 6 a.m., when there are no trains on the track, 3,000 maintenance workers tackle the repairs.
We always check the results of Dr. Yellow before we work.
Tonight, a team shores up a section of track to make it perfectly level again.
When we finish, we have to make sure it falls in a very specific range of accuracy.
Getting repairs done by daybreak keeps the schedule in order. But what throws things off is something no one can plan for. So within the system that prides itself on speed, efficiency, and everything running on time all the time, one of the few things that can complicate matters is this: the weather. Snowstorms can wreak havoc with operations.
The train of platform 23 is out of service. Please don't get on this train.
Hello, this is the General Control Center.
That's when the GCC springs into action.
Driver, would you please tell me about the weather conditions there?
Snow can be a huge problem for the Shinkansen. The moving train draws snow under the cars, and its high speed supercools it into ice. When the ice flies off, it can damage the cars and even cause an accident. Reducing speed to 70 kilometers per hour can help, but that won't make it a bullet train anymore. To reduce the effects of snow, the GCC activates a simple yet effective solution. Sprinklers shooting warm water to dampen the snow and keep it from icing up on the train.
Hi.
When the weather's clear, there's no stopping the Shinkansen as we head toward Nagoya.
So all along this trip so far, I've been surprised by the number of mountains and mountain ranges, but there's Mount Fuji. That's the most impressive view we've got of it yet.
To get to our destination, we're weaving around a lot of mountains and going through a lot of tunnels too.
I think this is the longest tunnel we've been through so far.
I think it is.
When you want a direct line that's as fast as possible, tunnels are necessary. There are 66 on the Tokaido line alone. One of them stretches on for 8 kilometers.
It goes on for a while.
For high-speed trains, tunnels solve one problem, but create another. The force of the train plunging through the restricted passage causes severe noise. It's called tunnel boom. To solve the problem, Shinkansen engineers came up with an aerodynamic nose borrowed from aviation design. It slices through the air, so it flows around the train, avoiding a buildup of pressure. Over the years, the shape of the trains has changed dramatically to make them move more efficiently and faster. Aerodynamic innovations like a sharper nose, covered wheels, and double walls to contain vibrations all improve performance. Even the design of the pantograph that conducts the electrical power to the train has been streamlined to reduce drag.
It's very smooth.
It's these small efficiencies that give the train more speed while using less electricity.
Nice.
Japan's densely populated cities have benefited hugely from these improvements. Faster trains mean more trains. But every decision to increase speed is carefully considered by everyone from the train's designers to its drivers, which prevents disasters like this. In 2013, the driver of a Spanish high-speed train took a curve too fast and derailed. The train was moving twice the speed limit on a sharp turn. 79 people were killed. No rail system wants this on their record, and Japan's Central Railway has worked hard to prevent such disaster.
So right now we're actually going around a curve, and even though we're traveling at almost 300 kilometers an hour, as a passenger, you barely feel it at all. And that's because a lot of work has gone into beating the laws of centrifugal force.
The solution to high-speed curves came from the Kamaki Research Center, hidden in the hills outside Nagoya. Access here is highly restricted. This is where all the innovations for the bullet train happen.
Most of the research that goes on in here is so secret, we're actually not allowed to show it, but they have agreed to let us in on how they've mastered high-speed curves on the Shinkansen.
Tatsuya Okajima is assistant head of the Kamaki Research Center. I'm hoping to find out as much as possible about his exclusive high-tech lab.
And how many people work here, did you say?
120.
Are most of them scientists?
90 people are scientists.
It's a huge team, but where are they?
Are most of the facilities there or there?
Secret.
Secret. Can't show any of it.
It took 5 years and over $2 billion to increase the train speed safely around curves.
Oh, okay.
What they came up with was a revolutionary idea called the body incline system. This simulator was built to test the effects on passengers going around curves at high speed. And we're gonna try it.
How fast are we going?
270 kilometers per hour. The first one is the one without body incline system.
When the body incline system is turned off, the high speed will push us sideways.
We are gonna hit the corner on 270 kilometers per
Okay,
hour.
we're hitting it right now.
Yes.
I can feel the force. Whoa!
To round bends and avoid throwing passengers and their drinks onto the floor, trains need banked tracks to lean into the curve. But high-speed trains need to lean a lot more.
The next one, we are gonna have the body incline system now.
Instead of banking or tilting the track, the Japanese came up with an ingenious solution. Tilt the train. Once the body incline system is turned on, Computer-controlled air springs under each car make the train angle into each curve. Every car tilts independently to the exact degree, at just the right moment.
Here we are going to hit the corner now.
I can feel a little we're going around the corner, but with the body incline system on, that didn't move at all, and I didn't move at all.
With this remarkable innovation, the train can travel at top speed around curves, making it faster and more comfortable than ever.
How much work and research goes into making this happen?
This is a result of the long-time research.
So, what's the next amazing innovation in the works?
It is a top secret.
After being a passenger, I'm really curious to see what it's like to drive one of the most high-tech trains in the world. We're inside the Railway Museum in Nagoya, where everyday citizens can get behind the wheel of a Shinkansen simulator.
General Control Center is telling me to go 285 kilometers an hour. I'm at 210. A little faster. Woohoo! Okay.
Being in the cockpit with the nose in front of you, it almost feels like you're piloting a spacecraft.
We're at 275. We're almost up at that 280 target. I got up to 285. ATC, automatic train control, has kicked in, limiting my speed.
Just like on the real bullet train, those safety features kick in.
There's that body incline system. They're actually tipping the train a little bit.
Taking curves at top speed seems easy, thanks to all that groundbreaking research.
She's gonna tell me how to stop. Okay, and now the brake.
And you have arrived at Nagoya Station.
That was a great ride, but I'm happy to be a passenger again. Now we're on our way to see a train that's about to change everything about rail travel, because it doesn't even use rails. The Maglev. This test train literally flies at speeds of over 500 kilometers per hour, almost twice the speed of the Shinkansen.
The science behind the maglev train is incredible. Superconducting magnets levitate the train and actually propel it forward.
The special guideway for the maglev is lined with coils of superconducting electromagnets. Coils for levitation raise the train 10 centimeters above the guideway. Coils for propulsion drive it forward.
It's the same science that's actually happening with this model right now. The maglev train is currently in test runs, and the plan is to have passengers on it in 2027.
This is the Nozomi Super Express, bound for Shin Osaka Terminal.
We're approaching the final stop on our journey.
Just a few minutes ago, we passed Kyoto Station, and in about 6 minutes, we should be pulling into Shin Osaka. So we're really close, and not surprisingly, we're right on time.
The world's original high-speed train continues to amaze, half a century after it first went into service. Uncovering the secrets of its incredible speed and safety record has been as thrilling as the ride itself. Meeting the people who make it all happen and experiencing the cutting-edge technology firsthand was a train lover's dream come true. My bucket list is getting shorter, except now I've added one. a ride on the maglev in 2027. Here comes the Canadian. Via Rail's world-famous transcontinental passenger train. It first hit the rails in 1955. Recently upgraded and overhauled, it's now mightier than ever. Barreling along a route with an incredible history.
1 man died per mile of track, so there's several thousand miles of track.
If you're like me and you love trains, you know that all over the world they connect people and communities. This one built a nation.
The Canadian is now arriving from Toronto, Cape Rio.
The Canadian rolls into Vancouver's Pacific Central Station, and the countdown to my great adventure begins. But before this train turns around and heads back east, an army of staff descends. To stock it,
so glasses, sugar, bananas, champagne.
Clean it.
Yeah, it's covered in bugs.
And check it from top to bottom. They swap out the locomotive's drive motor for servicing, scrutinize every millimeter of the steel wheels for flat spots caused by braking, and grind down any problem areas.
The passengers like a nice smooth ride. They don't like boom, 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 boom at 3 o'clock in the morning.
To prepare for my great Canadian expedition, I visited a guy in Toronto who's crazy about this train.
Look at that!
Jason Schron has an actual Via Rail carriage in his house.
This is incredible. Wow.
Complete with the soundtrack from a real journey.
Okay, so here we are in a train car in a suburban basement.
That's it.
This is amazing.
You're in a Via Rail coach as it was in 1980. We got a hold of it before it was scrapped and literally took it apart, took all the seats out, the windows, the doors, everything. So a lot of what you see is actually from that car.
What is it about the Canadian in particular? Why is it so legendary?
If you had to encapsulate the country into one object, the Canadian is an object that captures Canada because through it, you can experience the whole country. The Canadian it's like a time machine, actually. The equipment was built in 1954 and 55 when the train was first introduced. And Via Rail has gone through major refurbishments in 1981, 1990, and then again just recently. So you're in a modern piece of technology, but you're also in history. It's like a magnet. Rail fans from all over the world will come to ride the Canadian, and it is an experience that they will never forget.
At Vancouver's Pacific Central Station, 0 hour approaches.
And that's a complete time at 1816.
And our engineers, Brennan and Leslie, are finalizing critical details, figuring out exactly when and where they have to switch tracks to be sure they have a clear run ahead of them.
So trains go this way, and trains go that way.
It's like a puzzle.
It's a puzzle.
So we kind of zigzag on all these different rail lines, yeah.
Many different rail companies own the tracks and operate the switches that guide trains from one track to another. Passenger trains need permission from every rail company to get them on the right tracks at the right time.
Without this, we go out there without this, we don't have
serious
a job.
accidents.
We're in some big trouble.
Yeah.
Right. But the engineers don't have to make decisions all on their own. They've got support 24/7 from Operation Control in Montreal, where specialists like Nicholas Achillius keep a close eye on all 70 of Via's daily trains, even when they're 4 time zones away.
So it's our graph to know where the tracks are, where we can basically put 2 trains in the same area, and if a train can proceed or not.
He's also the go-to guy when there's an emergency.
Yes, sir. Operations mech. That's the most stressful thing, I'd say, is hearing that phone ring. Everybody's quiet until we pick up the phone and realize what problem we're dealing with. It could be a mechanical problem, heating not working, to somebody passing away on the train, or even a derailment.
Good to know these guys in Montreal will be keeping track of us. Once we leave Vancouver, the Canadian will travel eastbound 4,500 kilometers. We'll feel its awesome power as it hauls us through several mountain ranges and spectacular feats of engineering. 12 tunnels, 670 bridges, and ingenious construction over millions of hectares of swamp before hitting Toronto, its final destination. Before departure, our engineer, Leslie Redford, runs some checks. The operators need to know their brakes work, and all the bells and whistles too.
Bell, whistle. Red for emergency horn, or imminent disaster.
There is a backup in case the engineer is distracted, loses consciousness, or worse. If he doesn't touch the brakes or gears for 30 seconds, an alarm goes off and he has to hit a response button to show he's paying attention.
If this button is not depressed, then the alerter will set the train brakes and bring the train to a stop.
This locomotive, an F40 PH2, a legendary workhorse, weighs in at almost 118,000 kilos, as heavy as 4 Sherman tanks. At 18 meters long and 5 meters high, it's the size of a small house.
Your attention, please. Economy passengers on Via Rail Canada, please get ready to board the train. Thank you.
The adventure starts now. Hello, I'm Teddy.
Hey, Bert.
Nice to meet you, Bert. Your first time on the trip?
No, it's my third. It's a great way to cross the country.
Any advice for me for living for 4 days on a train?
Use the bar cart.
The bar car. I think we're related.
And here we are. Welcome.
Oh, cool. Oh, this is great.
Everything you need.
Where is the bed?
The bed is hidden in the wall. What you get here, right there. These chairs fold right down very flat.
Yep.
And I have a special key. I'll be coming around later on while you're at your meal, and I'll be pulling down the beds. What happens here is this one drops down like a Murphy bed.
Okay.
And if necessary, there's another one that drops from the top to create bunk beds.
Oh, there's a double in here.
It could be a double if you want. I assume you just want the one today.
Oh, I'm just good with the one. Yeah.
All right.
All aboard!
The train is so long, it was split to fit the platform during servicing. Now, the front half moves forward, switches tracks, then backs up to connect with the rest. And we're away. As Vancouver's lights grow dim behind us, we cross the first of those 670 bridges, catch glimpses of the Trans-Canada Highway, and see a lot of freight trains. Some of them are 200 cars long. When we meet them traveling in the wilderness, usually on a single track, our shorter passenger train will switch over onto a siding to let the big guys pass. We departed Vancouver after sunset, so because this is such a long journey, obviously a lot of it is going to take place at night, and if it was daytime, you would see the Fraser River just on this side of the train. I'm definitely taking that advice I was given. Time to hit the bar car and meet some fellow travelers. You guys having a good trip so far? Yeah!
This is the first time we've taken a journey, not a trip. Being able to just sit back and relax and really see Canada. You really do. This from a totally different angle.
What do you think of the ride? Yeah,
Love
how come?
it. Here, I get to sit down, I get to meet people, and it's an enjoyable journey.
We start hitting tunnels about 100 kilometers northeast of Vancouver, heading into our first mountain range. That's when the real work begins for the locomotive and its mighty engine. It's hauling 18 loaded carriages that stretch more than half a kilometer. The diesel engine has 16 cylinders and 3,000 horsepower, giving it the pulling power of half a dozen tractor trailers. It runs a massive electric generator, powering 4 traction motors that drive the wheels pulling the train. When these locomotives were built in the 1980s, few machines on Earth could match the F40's strength and staying power. Then, a few years ago, VIA had to decide, scrap them or overhaul them. The result? Many innovative upgrades that make the locomotives better than ever.
We wanted to get a fleet that was going to take us for the next 20 years, be more fuel efficient and easier to maintain, and also increase the total power available in the locomotive. And all the removable components were removed, and they were sorted. Some had to be just thrown out for garbage, some were sorted for reuse, some were then rebuilt, and others were renewed completely. The locomotive was stripped down to bare metal. All the repairs that needed to be done, the body repairs, the corrosion repairs, some major patches had to be put in place.
But VIA did more than rebuild. They also found better and more efficient ways to operate the engine.
We had to add this section of body here, and we had to add this bulge up here to accept the cooling system for what we call the genset. And the genset is what gives us the ability to save over 10% of our fuel bill on our F40 fleet. Now in here you can actually see the genset. The yellow piece is the diesel engine.
This diesel engine generates 500 kilowatts of power for the train's hotel needs. Everything from lights, heating and air conditioning, to running the kitchen and the toilets.
And all of this, it allows the main engine to operate much more fuel efficiently than it did before.
It's just after midnight when we pull into a siding for the first shift change.
Okay, we had a clear signal coming in. 20 cars tonight, 2 engines, no problems with the power. Okay, good to go.
Time for Leslie and Brennan to hand over the controls.
Yeah, as long as there's no more delays, the train will make up time.
The new engineers will keep a close eye on the clock as we head deeper into the mountains.
I say to you, good luck.
It's a real challenge struggling to stay on schedule while pulling over for so many freight trains on a busy single track. These engineers are well trained and understand that fine balance. They know that a moment of inattention could lead to big trouble. Aboard the mighty Canadian, we're 12 hours into an epic cross-country journey. When the sun came up this morning, we were in the BC interior near Kamloops.
Right now, just on the other side of this, we're paralleling the North Thompson River, but we've basically been passing the side rivers the whole time, and it makes a lot of sense because there's rivers that originally cut a path through these mountains.
This is Little Hell's Gate, where the North Thompson squeezes through a narrow gorge, creating wicked rapids.
And I kept this window open all night, and you'd sleep for an hour, and then you'd wake up for 10 minutes, and you'd see a little town on a hill, or you'd see a freight train pass.
In the clear light of day, it's easier to see what's happening when we meet those trains. I can see the sidings now, where we can pull over. It makes sense that our shorter train will have an easier time switching onto that parallel track than the long freight trains. The signal system tells engineers when and where to do this, so they need to know their signals. Track clear, proceed, slow down, and stop. Missing a signal or switch can derail a train, or worse. In 2008, the engineer of a packed commuter train in Chatsworth, California, missed a red signal and collided with a freight train, killing 25 people. Sure makes me appreciate the skill and alertness of the guys driving our train. The Canadian is more than a tourist train. People who live in remote areas, like Valemount, a small logging town, can call ahead and ask it to stop.
This was where you came this morning, the North Thompson River.
Okay.
Matthew Wheeler is a local photographer. His family has lived in this area for generations and relied on the train to connect them to the world.
The passenger train was the only way to get to the city for dentists and all that sort of thing.
A real lifeline, right?
Yeah, there was. There was no highway out to the west. It becomes a traveling village.
Tell us about where we are. We're in Robson Valley now.
We're in the Robson Valley, which is the Rocky Mountain Trench, which stretches from Yukon to the States, and the Fraser River fills it. That's Robson.
That is impressive.
It's 3 kilometers from top to the valley floor. If it's clear at the top, it's like a beacon. You can see it from 100 miles.
It's a beautiful sight, but don't be fooled. We're in wild country where forest fires and rock slides can devastate a mountainside. Avalanches can wipe out tracks in seconds, as one did in 2007 on a different rail line a few hours south of here. But sturdy snow sheds protect the trains from most avalanches, and special detection systems pick up signs of falling rock.
The railway has poles with wires, and if something comes down and breaks one of those wires, then it'll detect the broken signal and someone will come out to have a look.
No hazards on our route so far, just some spectacular scenery.
What would Canada be without this line?
It wouldn't feel like a country anymore. It really wouldn't.
It was the railroad that made Canada a country. Building the first transcontinental route was brutal work. It took more than a decade to survey, then 4 years and tens of thousands of workers to lay down 4,500 kilometers of track. The last spike was hammered in 1885.
Very dangerous stretches of track to build because of hanging off the sides of these raging rivers. There's estimated about 1 man died per mile of track in building the Canadian Pacific Railroad.
Wow.
I think that there's several thousand miles of track.
For most passengers, this trip is not about getting from one place to the next. Being on the Canadian is the destination. The scenery out the windows, our big screen entertainment. For die-hard rail fans, a trip like this, in these iconic vintage cars, is highly prized, as is collecting them. The models, that is. Our friend Jason Schron spends his working life crafting perfect replicas and selling them around the world.
So kind of little seats in there, so that this is the coach car?
This is the coach, right? The coach is basically the bread and butter. This is if you're going from A to B, especially if you're not going overnight, you're gonna be in the coach. And to an average person who's never ridden the train, they think, oh, that's like an airplane. It's not like an airplane, okay? You have a lot of space. You've actually got a leg rest that folds out. The seat goes almost all the way back. It's a very comfortable place, and a lot of people will actually go all the way across Canada staying in the coach.
Sleeper car, I presume?
Yes, this is actually a manor sleeper. They've got single bedrooms called roomettes. They've got open berths called sections, and then they've got the bedrooms.
Ooh, so which car is this?
Okay, this is a dining car.
Yeah.
The food on the Canadian is something else. It's really amazing, and it's one of the few places anywhere in North America where you will have fresh, prepared food on board from fresh ingredients by chefs. Wonderful thing about dining on the Canadian is it hasn't changed. So it's like you're in the 1950s and you are getting beautiful service on the train 1950s, and it's still great service. You really feel like you're being taken to a very classy restaurant 60 years ago. And at this end of the car, you have the kitchen, and then you have an aisle going along as well. And the kitchen is very, very, very tight. Everything has its place there.
So as a fan of trains, this car instantly recognizable as the Canadian.
It's very unique to the Canadian to have these dome cars. And then the Skyline's got a whole bunch of things to do. It's actually called on board the activity cars. And the Skyline has 3 sections to it. So it has the lounge at the end, which I'll tell you is actually the most comfortable lounge in the train, in my opinion. It's got these big curvy seats. It's very, very cozy. Cool. You've got the dome on top, and then you've got a coffee shop area on the other end where you can have activities, you can play games, you can meet people, you can have a snack. I mean, it's a just nice place to hang out.
Sleeper car?
Well, this is a Chateau Sleeper. The Chateau Sleepers have recently been refurbished for prestige class, so if you really shell out a lot of money, you'll be in a Chateau.
The L-shaped couch pulls out into an extra-large bed, and each prestige room has its own shower. All the private bedrooms have their own toilets. And guess what? They don't empty onto the tracks. I checked with the guy in Vancouver who's in charge of them.
First of all, we can't just flush out onto a track, right? That's been forbidden for years. At one time, toilets could be flushed on the track, which was pretty bad. And then they came up with this whole idea of flushing into retention tanks. But there's no place that you could put big enough sewer pipes, like on a house, like 3 and 4 inch pipes that could drain down on grade and into a tank. So they have to be basically sucked into the tank through these 1.5 inch pipes. When you want to flush an individual toilet, you're going to press the button. Then the main brain under the car fires up the vacuum ejector, basically send a signal back to the single toilet and say, go ahead and flush. 20-car train will probably have about 130 toilets. They're all like my little children. So I tell people, I got 130 or 40, 50 children out there that I have to go out and babysit every day, you know, so that's how I feel about them.
Good to know Larry's taking care of that business. Now back to our tour.
The end of the train is the park car. They're named after national parks in Canada. And the Bullet Lounge is the one at the back. And that is really an iconic symbol of the Canadian. Now, the Canadian was a product of its age when it was made. So in the 1930s to 50s, streamlining was all the rage. And what is a miracle is that we still have it running today. They're all gone from regular service. So people travel from all around the world just to ride in this car.
An economy ticket from Vancouver to Toronto starts at $700. Travel in luxury in the brand new Prestige car in a suite for two will cost around 7,000 Canadian. Time to check out that Skyline Lounge.
Dark ale?
That looks good. You know what I'm gonna pay with this $10 bill, which, check this out, this train, the Canadian, is on. Isn't that cool? Did you know that?
That is way cool.
Isn't that awesome?
I just found out about it. I think it's great.
That's great. So why did you want to take the Canadian, Bob? And there you go, Mark.
Thank you very much.
Thank you.
Oh, how cool is it that it's not my fault that nobody can talk to me for 4 days because there's no internet? That I have 4 days completely free.
So part of this trip was an intentional unplug for you?
Absolutely.
Wow.
Yeah. And literally feeling like we've gone back 60, 70, 80 years. That's part of the allure. No, this is the way they did it in the old cars. This is the way we want to do it. That technology is still so valid.
We're coming into Jasper National Park, a UNESCO World Heritage Site. It's wet outside, but that's not going to stop me from getting out there.
So every time the train stops in Jasper, you do this? Wash all the windows?
Every time.
This is where I get to stretch my legs and arms, doing my bit to uphold the Canadians' picture-perfect reputation. Tomorrow, we meet the guys who never have time to look out those windows. They'll be too busy trying not to lose their fingers
Table 5.
when we hit the bumpiest part of the journey. The legendary Canadian has crossed the Continental Divide and conquered the Rockies. With the mountains behind us, we're now picking up speed.
Today, we wake up to the Saskatchewan prairies. Now this flat, undulating land, wheat fields everywhere, and wheat and Saskatchewan and the railway all totally intimately tied together. Every small town along here has a grain elevator, bringing wheat up to the passing rail cars. So the history of Saskatchewan is very much the history of this railway route that we're on right now.
Pioneers flocked to this area in the late 1800s. The government was giving away land and promising prosperity.
You really do get a sense of how much the railway built this part of Canada in every way, especially here in Saskatchewan. It was a huge, huge lifeline for people, but also for building the towns for business.
Okay, order up table 5.
140 meals come out of this tiny galley every day.
We open at 6:30 in the morning, pretty much go till 10:30 at night.
Wow.
So it can get a bit crazy. Whoa. As you can see, it's a challenge.
Have you ever put your hand on the grill accidentally or anything?
No, but I've been lurched that way and I managed to catch myself. This safety bar helps a lot as well.
It's a big thing, right?
Right.
This is why we have the rails around here. The fans will slide and it'll stop them sliding right up.
Oh, right.
So it's a safety issue too. Also works as a good hand grip when you're falling over.
Hey.
For the cooks and passengers, how smoothly the wheels ride really counts. The wheel sets on the train are made up of 2 steel wheels on a fixed axle that fits precisely on the rails. The tread of the wheel is coned or angled, and the rail rounded and angled inwards. That's what keeps it on the tracks. The actual contact spot between the wheel and rail is barely the size of a dime. The less resistance between the two, the smoother the ride. The flange on the inner side of the wheel never actually touches the rails if the train is rolling smoothly. It's only there to prevent derailment. Before every journey, the maintenance crew in Vancouver make sure the surface of each wheel is perfect.
The bastards like a nice smooth ride. They don't like bump, 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 bump.
They start by eyeballing every single wheel set, looking for damage to the wheel's surface. Damage like skid flats, caused when the trains slide or skid during abrupt stops or emergency braking. Any flat spot on the round wheels makes for a bumpy ride. So when damage is detected, the wheels are sent to be trued or reprofiled.
This machine is designed to remove the defect from the wheel.
A special lathe or milling machine with multiple cutters on each side is used to shave off thin layers of steel and restore the wheel's profile.
Should it get another defect in it, it'll come back and we put back on the machine and true it again.
A wheel set on the Canadian can be trued up to 4 times and usually lasts about a year. During that lifetime, they do a lot of rockin' and roll.
Is there a certain part of this journey, Vancouver to Toronto, that's the roughest for you guys?
Pretty much this part in the prairies, because it's
yeah,
straight line, so we can go as fast as we can, right?
Right.
We're in the mountains, we tend to go slower around by the rivers, which is a good thing.
So I came back here in the most jerky part, right?
You picked the perfect time, Jeff and I.
Line is up.
Line is up.
Whoa.
There's the feet, Chef.
Yeah. So Chef Ken, can you tell me about these footlocks here?
I just put my feet under here and I lean back sometimes. Hold on.
Like that?
That's it. It ruins your best shoes though, be careful.
Right.
You use all kind of tricks on the train, you know?
Yeah, you kind of find every spot to grab.
Yeah, you lead your knees on here as you're cutting. When you're using a knife on the train, it's pretty fast. You're rocking around like this. You need to stay balanced, right? You don't want to get your fingers under the knife, right? So, but when you're moving back and forward, you kind of get used to the movement of the train, so you can almost anticipate which way it's going to go, you know?
Over the years, how much have you guys bumped into each other?
Lots of times. We stay kind of friends.
They've logged a lot of time and distance through all that bumping and balancing. The Canadian has traveled a mind-boggling 97 million kilometers in its lifetime, the equivalent of 250 trips to the moon. I'm about to learn how that's even possible. We've been rolling through the prairies all night long, heading toward the halfway point of our journey, Winnipeg, Manitoba. I'm finding it hard to wrap my head around the size of this country and how amazing it is that the Canadian has done this journey more than 2,400 times and racked up 97 million kilometers in the process. The secret to the Canadian's long lifespan is here at Via's Maintenance Center in Montreal. The eyes of the best mechanics in the business are all over these locomotives. They get serviced every 7 days, every 14 days, and this F40 has rolled in for its E-inspection, which happens twice a year.
They're going to be doing the inspection of the engine, all the electricity, the communication. They'll look at the windshields if they're cracked, all the safety items.
Turns out this locomotive arrived just in the nick of time. When a mechanic checks out the massive V16 engine, he discovers something that's not supposed to be there.
There was oil in the base where the engine sits. It's supposed to be no oil. We need to do a thorough inspection on that.
To get at the problem area, the team has to use 2 15-ton cranes to hoist the engine out of the locomotive.
Put it on the side, and that's where we're going to start investigating exactly where the oil leak is coming from.
It might take days to find the problem. With a situation this complex, engineer Maxime Labrie steps in to troubleshoot.
So we look at places where there could be evidence of leakage, if there are gasket missing or if there's sealing surfaces that are not working properly.
Vous ayez l'air bien occupé puis restez dans le même groupe pour essayer de comprendre comment ça fonctionne.
They're measuring actually what's the gap between the crankshaft and the housing. If the gap is too big, we fear that it might leak oil from there. So that's why we're making those kind of measurements to make sure that the engine is in good condition.
It takes 24 hours before Maxime's crew zeroes in on the cause of the problem. Turns out a clog in the drain under the engine made oil spray out everywhere. Once fixed, it's back on the rails again.
Since we hold passenger trains, it's very important to make sure that the trains are in good condition and we don't have road delays because of the equipment condition.
That attention to detail means breakdowns in the middle of nowhere are highly unlikely. We're now passing through an area of Manitoba known for its wide river valleys. To span the deep gaps in the landscape, trestle bridges were built. The one we're about to cross, the Uno Bridge, is close to 500 meters long. It's supported by steel trestles, and it stands over 30 meters high.
Hi there, how are you? Enjoying your journey with us?
Service manager Chris Nadeau can't even begin to count how many bridges he's crossed during his career on the Canadian. But the thrill of it never gets old.
Even when I'm not working, I love being on the train. It opens your eyes up a lot to see what's actually out there. I've driven across the country before, but to take it by train is a whole different experience. Of course, your first few trips, you're too busy working to look out the window.
Yeah.
But once you get the hang of things and have a chance to appreciate the scenery, we are so fortunate to live in the most beautiful country in the world.
In the meantime, my room is being serviced, and I want to see firsthand how it's done. Are people on the train pretty particular about their beds, do you find?
Well, you know, they're pretty happy by the time the end of the day they get to have any type of a bed, but
That's right,
it's always nice to climb into a nice, clean, crisp bed.
It is, yeah.
Every section of the track across the country has a little bit of a different cadence.
Okay.
So without opening the window of the train when I wake up in the morning, I can tell whether we're on time. You know, when you're going through the Rockies or through the Fraser Canyon, we get the creaking of the train going around the corners left to right. The prairies, you get the hopping, skipping, you know, rattling, everything starts bouncing around.
When you're doing stuff like this off the train, does it feel weird not having the sway? Because you can really feel it.
You know what? I don't even make beds at home. I don't make beds or wash windows. I've actually told my wife that I shovel coal on the train because I don't want to have to do that when I get home.
That's what she thinks you do?
Yeah, well, it's been working so far.
We're slowing down as we approach Winnipeg, the halfway point of our journey. In urban areas, it's absolutely critical that the brakes of this mighty machine are working at 100%. Every train's brakes are tested before leaving any station to make sure there's enough air pressure in the system to reach all the way to the back wheels of the last carriage. Another thing they pay serious attention to in Montreal.
So I'll manipulate this handle here, and I'll put it in any position that I want just to make sure that the brakes apply. So the first brake position is the minimum brake position, which is the first notch that you encounter when you move this lever.
One of the F40 locomotive's trademarks is a rugged air braking system. Lucas Simsiak knows it inside out.
So this locomotive has a compressor which will pump air into reservoirs, which are beside me over here. So the compressed air goes in this piston. When the locomotive engineer moves the handle, that piston gets pressurized, pushes on a set of linkage, which will apply brakes on each of the wheels.
Many people think that trains take so long to stop because of their enormous weight. Not so, says Lucas.
It is actually not at all the weight. It's because of the adhesion of the wheels on the rails. Trains run on steel wheels on steel rails. Compared to tires, you slip very easily between two steel surfaces. So you're limited on how hard you can brake before the wheels lock. For that reason, you cannot brake above what the available adhesion between two steel parts is.
In a worst-case scenario, the driver needs maximum adhesion instantly.
Emergency situation requires emergency braking.
When the lever is in emergency position, maximum air pressure is forced into the braking system.
Unfortunately, sometimes this is not enough and they will collide in most cases.
As we pull into Winnipeg, our brakes are serving us well. This is a 90-minute pit stop to restock and switch crew, including the service managers. Chris Nadeau hands over to Sonny Restio.
Everyone's behaving, so torch is yours, brother.
Thanks, buddy.
Have a great trip. We'll see you soon, man.
The train is restocked, the crew and new passengers board, and the Canadian is ready to move on.
Okay, for doors right-hand side, Winnipeg. Thank you very much, gentlemen. Attention on-train service personnel via 2. Once again, you're okay to open up your doors right-hand side. Winnipeg Terminal, SM2 out.
Heading into Ontario bush country, there'll be surprises, unscheduled stops, and some unexpected cargo.
Moose?
Yeah. We're past the midpoint of our journey, having traversed incredibly varied landscapes. 2 more days to go on our journey to Toronto.
So here we are, our third morning, and surprise, our third completely new landscape. This is Ontario. We crossed into the province overnight, and we've just passed Sioux Lookout. We're about an hour past that, and we're en route to Sudbury. This is the Canadian Shield that we're seeing. It's this vast, dense layer of Precambrian rock.
On top of this wide area of Precambrian Shield, we find muskeg country. It was a big challenge to build the railroad across these millions of hectares of bog, as big a challenge as it was to get through the Rocky Mountains. This gigantic expanse of wet, dead, and decomposing vegetation lies on top of the hardest rock on Earth, the Canadian Shield. Railway workers used dry earth to fill in the holes, wove tree branches to bridge gaps, then poured tons of rock and gravel on top to pack it solid and level it to create a rail bed. As harsh and wet as this place is, it's still home to remote settlements, and the Canadian serves them well.
The railway continues to be, for the people in the small communities, the inaccessible communities, it's their lifeline. Specifically in the summer times. In the winter time, they can get by with winter roads, and they can get all their commodities and such brought in that way. But in the summertime, there's just no accessing the communities.
This is Collins. Population, about 30. No roads in or out. Only air evacuations for medical emergencies.
Okay, so there's a couple passengers you're gonna get. We'll do the bag. Okay, I'll leave you with this, and I'm gonna go crack the door.
Yeah, they have to get all their supplies, out of town, so they only recently got electricity here. We're running about 2 hours late, which is, it's not too bad for this train, generally speaking. 2 hours you can live with. You can almost make it up on the road if you get a couple of breaks.
Almost, but even the best train schedules can be delayed by latecomers.
Yeah, last minute arrival, so luckily for them, we were still here when they decided to show up. So we usually we'll give the horn a couple toots before we pull, and you'll see them come running. We call them marathoners. Good day, how are you? Up you go, young man, go to your left. Hey, we almost missed you, eh? What happened? Yeah, that's what we heard too, but we got you. Hopefully there's nobody else.
Yeah, no.
Okay, fantastic. Guys, grab a seat and I'll come and see you. This train is their lifeline. They use it, they do all their shopping in Armstrong, and they bring their supplies in by train. We carry building supplies in the baggage car. I've seen ATVs up there. I've seen refrigerators. I've seen hamsters, guinea pigs, lots of dogs, of course. So we've had some really strange things in there.
There's no end to surprises along the Canadian's route. Grocery shoppers hitching rides to nearby towns, cottagers flagging a lift to their cabin in the wild. Sometimes, even caskets get a ride. And tonight, it's moose hunters, hopping a ride out of the bush with their catch.
Moose? How many?
One.
With that many legs?
Over his years on the Canadian, Sonny has seen it all. Mostly good, except the one day it was really bad.
Unfortunately, our train got hit by a logging truck carrying 2 trailers full of logs, and we were doing probably around 75 miles an hour. And the engineer almost seen it coming. He seen the guy wasn't going to stop. He slowed the train And we went from 70 to 0 in 13 seconds, and we put 14 cars on the ground. When I say on the ground, 14 cars derailed.
But you were okay.
I was okay, and the best part was I had no injuries on that train.
That's not a bad result for
No, it's not,
derailment.
considering it's midday and we got people in the dining cars and you're going that fast. We evacuated the coach. By the time I got up there, we already had sirens in the distance and local firefighters approaching the train and assisting. Without anybody saying anything, everything fell in the way it should with the emergency calls, the evacuation of the train. I feel totally confident that should the situation ever happen again, my passengers are in good hands and we'll do okay.
Operations, Nick.
Whenever there's an incident, having to either speak to the engineers or right after the incident happened, hear the person's voice, maybe sometimes trembling, affected, that's quite something.
We've had a few, I can say, very stressful. There are times when you feel it. I mean, the emotions come running, and you just have to deal with it. You gotta push through it and think about the people that are on the other end and the people that need your help.
This trip has been light on stress, heavy on fun. But one thing still needs some work, my train legs.
More water, anyone?
We've been riding the rails for almost 4,000 kilometers, all the way from Canada's west coast. And we're closing in on our final destination, Toronto.
So, morning number 4 and our second morning in Ontario. We woke up yesterday in the province too. It gives you a sense of the massive scale of this part of Canada. So as we head into Toronto, which is Canada's biggest city, you also really realize how big this province is, but how concentrated the population is in southern Ontario. And it's also the most populated part of the country. I'm basically a train sleeping champion now. I'm sleeping pretty much as I do back at home, getting used to the shakes a little bit. I'm wondering if when I get home it'll feel weird to not have that jostling in the night, because my body's kind of cool with it now.
So I've mastered sleeping on a train, but what about train legs?
Hey, so Renee, part of the job of a senior service attendant, serving in the dining car.
Yep. So the first thing is you want to kind of spread everything so that it's balanced. So I like putting them all the way around. So for walking, because the train can lurch at any moment, so I like to keep my legs like hip distance or more apart.
Okay.
And my knees are always a little bit bent, so I can really kind of move with the train and absorb.
Be one with the train, right?
Be one with the train. This is my first waiting opportunity, so.
Oh, really?
I hope I can get another job where the building doesn't move.
That would be nice.
That'd be really
great.
nice.
Okay, wish me luck, Renee.
You're right. You'll be good.
All right. Morning, folks. How are you? Water for anyone? Yeah, and obviously when you take the glass off, the tray changes, but that's compounded because of the train movement. How am I doing?
Great.
Really? I love when you lie to me. You're gonna have to share that one, folks. Here we go. Okay, all right. Oh! You guys. Whoa! More water, anyone?
As the journey winds down, I can't stop thinking about this incredible experience.
Every morning we woke up and it felt like we were in a different land altogether. And I knew that going into this, but it's completely different to see it, especially on a journey like this. And the other thing that I've really got the sense of now on a personal level is how much this railway and this train connects these tiny isolated communities throughout most of the country, and what a lifeline it is for people, and how it must have really helped build this nation. Oh, and it's just also been completely awesome.
The Canadian, the only stainless steel streamliner left in North America, has completed another 4,500-kilometer cross-country journey. In less than 12 hours, it will turn around and head back westward. The legend rolls on. What a trip. An engineering wonder, blasted through granite and ice. In wicked winter weather.
Those bridge builders were something else.
A century-old railroad that survives and thrives.
It's not just a job, it's an adventure.
Thanks to a rare vintage fleet of diesel and steam.
It is a sight to behold.
It's a narrow-gauge railway that crosses mountains, valleys, and an international border as often as 12 times a day. In a fjord on the Alaska Panhandle, winter's almost over. The town of Skagway is waking up. And the White Pass and Yukon Railway is firing up, hustling to get their prized fleet of locomotives up and running for a non-negotiable deadline.
We have about 3 more weeks left before the first cruise ship comes in, and if these things don't run, we don't make money, and it doesn't make people very happy.
When cruise ships come around this bend from May through September, they'll deliver hundreds of thousands of tourists to ride the White Pass and Yukon route. A historic railroad with a vintage fleet of 19 diesel-electric locomotives, 85 carriages, and a custom-made steam locomotive built in 1947. Right now, in the month of April, Skagway is a quiet little village. But in May, it'll transform into a boom town. And that's nothing new around here. Almost 120 years ago, gold was found on the other side of the mountains. And because Skagway is the closest seaport, the Klondike gold rush went right through here. The rush for riches made the unthinkable possible. Construction of a railroad from Skagway, Alaska, through the treacherous White Pass, 177 kilometers to Whitehorse, Canada. Today, part of that route is open for day trips, the shortest, a 32-kilometer excursion to the White Pass summit. Other trains cross the border into Canada, as far as Fraser and Bennett, BC, and Carcross in the Yukon. Maintaining this mountain railway is a non-stop commitment. And keeping those rare old locomotives in top hauling form is a huge challenge.
They quit really making parts for these in the 70s and 80s. So we're depleting every little warehouse we can find for these parts.
One of the diesel-electric locomotives just had its pre-season inspection.
We have some plates that are missing when we did our inspection, and to let a train go knowing something's wrong is a huge violation.
He's talking about the wear plates that keep the wheels and axles from shifting too much. But to get to those plates, they have to drop the whole motor assembly. There's a lot happening outside, too. Clearing the track and making it safe for tourist season. It's a huge job. Engineer John Westfall has driven trains up the White Pass for 4 decades. He and conductor Pete Gifford are hooking up a work train to take a snow removal crew into avalanche country, where experts have been keeping a close eye on falling rock and snow.
Well, the number one thing we're looking for is to see if there have been any avalanches occurring. Because if we've got avalanches that are actually running, we know that things are unstable right there.
Bill Glued is one of Alaska's top avalanche forecasters.
You can see quite a few of our major avalanche paths. We've got Slippery Rock here, which is a big rock slab. that releases snow and ice.
And within 1 kilometer of slippery rock, several other slide areas, including one that released a giant pile of snow onto the track last week.
This would be a place where I would need to do some snow pit studies.
The work crew will ride in the caboose. Bill's bringing along his skis and avalanche kit.
We work our way up to where we left the dozers off last night. And the operators will start pushing snow from there.
The Alco engine, built by Montreal Locomotive Works in the 1960s, pulls work trains and loads of tourists. It has mighty hauling ability, 1,200 horsepower, with a hefty prime mover, the diesel engine that rotates the main generator. It produces enough electricity to power the locomotive's 6 traction motors. The work train has climbed almost 600 meters since it left Skagway and is close to slippery rock in the area Bill Glued wants to test.
We want a place without too many rocks with a good clean snow slope.
Deep into snow country, the heavy equipment operators are ready for action. One machine moves ahead, plowing a rough path. The other works right in front of the train. Without these guys, there'd still be snow on the track in early May when the first tourists arrive.
We're looking at the end of the track for us at the moment. We can only go as far as they've cleared the track, and this is it. So Brad will slowly keep working ahead, and we'll slowly keep creeping on him. We're getting into the deeper snow, and there may be days where we don't really gain much of any ground at all. They will probably make maybe a quarter of a mile.
Time for Bill to check the stability of the snowpack. He measures out an area the length of his skis with a predetermined width that corrects for his weight, and uses those dimensions to form a cube-shaped test block.
So the first step is to smooth it so we can see the layers. And also as the shovel cuts through, you can hear the sound and you can feel the layers.
Figuring out which layers of the snowpack are hard and soft helps Bill predict how easily snow will shift and slide. Next, he'll try to cause a mini avalanche by jumping on the snow cube, increasing the impact with each jump.
Getting nothing, so we'll try to push it sideways.
The snow is not shifting easily today, and that's a good sign.
So there weren't any weak layers to make slabs. So it's a good result for stability.
There's no immediate avalanche threat at this spot, but that can change quickly at this time of year. Back at the shop, mechanics have extracted the wear plate that keeps wheels and axles in place. All those trips up and down the mountain last season have worn it down to nothing.
This is what's left of the wear plate. This is what it's supposed to look like. The thickness that is from this to this.
They weld on a new wear plate. Another job done on the pre-season checklist. On the other side of the shop, they're fixing damage to the carriages that happened over the winter.
The frame is made out of tubing, and sometime in the winter, water got into the tubing and froze.
which pushed all the inside panel towards the outside, so we had to cut them out and replace them.
Upstairs,
Hi, this is Keith from White Pass. I was calling to get an ETA on our prime mover.
electrical supervisor Keith Evans is under pressure. 2 of his locomotives are waiting for overhauled engines, or prime movers. Right now, they're just sitting there with big holes in their middles. The locomotive's main generators have already been reconditioned, but Keith can't install them before the engines get here, via a barge that only comes up this remote waterway once a week.
If one person doesn't do their job and it misses it, I could be backlogged by a month, waiting for a part to come from Seattle.
A month-long backlog is not an option for Keith. Tourists are arriving in 3 weeks, so he can't afford to have any of his locomotives sitting idle. A month after our first trip to Skagway, Alaska, the steam engine is rolling out of winter storage for a pre-season test run. An 87-kilometer round trip across the Canadian border on the White Pass and Yukon route. In the shop, there's been progress on the diesel-electric locomotives. This one finally has its engine, also known as the prime mover. It arrived on last week's barge from Seattle.
As you can see, our prime mover is set in place, and next is to set the main generator in. We sent it out this winter to have rebuilt.
Keith has to move quickly because the tourists are here. On this day alone, 4 cruise ships will tie up in Skagway. And by 7 a.m., the first of 8,000 passengers start coming down the gangway to the dock.
And for a lot of them, a big part of their Klondike adventure is riding this world-famous train.
At the White Pass rail yard, staff have arrived hours earlier to get today's trains ready. They come up with a plan based on cheat sheets to factor in the number of bookings for today's excursions and which equipment is available.
A lot to do. And we got about, what, Pete, 3 hours to get it done? Yeah, so we're gonna be racing around.
Pete and Tom set a brisk pace, matching locomotives with carriages, and back them down to the appropriate dock and cruise ship.
Victor, 25 more.
Victor, 25.
Meanwhile, up on the mountain, the guy that owns the track right now is Foreman Brian Thompson. He patrols every morning to make sure the line is safe for passenger trains.
This is a rock that just came down a couple days ago, and luckily it didn't hit the tracks.
A rock slide can damage the track, sometimes even rip it out altogether.
A long time ago, this bridge was completely taken out by rock fall. Just the decking, the ties, and the rail were suspended in the air. It's not just a job, it's an adventure.
No rock fall today. This part of the line is clear. So Brian sends word back to dispatch in Skagway.
U.S. track inspection complete. 2021 will be working between White Pass and Glacier.
Dispatch out.
This will be the crew on my journey today. Engineer John Westfall, who drove the work train last month. Conductor Chris Williams, reading this morning's operating procedure.
Number 21 at White Pass, in care of number 21 at the shops.
And brakeman David Dobbs.
All right, guys, you're good to go.
There'll be 10 trains heading out today. Most of them will climb 32 kilometers to the White Pass summit and turn around at the Canadian border. But a couple of trains, including mine, will cross the border and travel another 13 kilometers to Fraser, BC. It'll take us about 2 hours to get there.
Good morning. I'm Kelly. I'm going to be your personal tour guide today. You are aboard a railroad that was built over 100 years ago during the historic Klondike Gold Rush.
Our brakeman, David, does final rounds. And we're off. We're only a few kilometers into our journey, but I'm already seeing this land the way railroad pioneers saw it. Today, the railway is recognized as an international civil engineering landmark. Same category as the Eiffel Tower, the Statue of Liberty, and the Panama Canal. No wonder it's a dream come true for rail fans. Juan came all the way from Chile for the experience.
Well, I can imagine, like, I don't know, in the old days, all this train packed with people, looking with, I don't know, with some dream of getting some gold, and I think that's great.
I feel like I'm stepping back in time. I feel like I'm one of the old railroad executives riding my train, you know, checking out the line to make sure everything is perfect.
It's exciting out on the deck, but I also want to find out more about these incredible sights.
That's the Skagway River, right?
That is the Skagway River, and there is one section that is a giant whirlpool. It is technical class 6 rapids. A lot of us will use poetic license and tell you that nobody survived navigating the river, but in actuality, nobody's tried to navigate that river.
So I probably shouldn't try.
I would not.
No.
Well, you can be the first. I can tell your story next year.
Oh, yeah. Be a sad ending to the story.
After more than 7,000 runs, John Westfall knows every kilometer of track, forward and backward. But he never takes anything for granted, especially going downhill.
The goal is to run the smoothest train that you can, and that's the challenging part. Because there's controlling the slack and the speed at the same time, and the changes in the grade.
There's slack between the carriages because of movement in the couplers, springs, and hydraulic systems, adding up to several feet of slack across the length of the train. Going downhill, the engineer has to compensate, making sure the carriages bunch together as gently as possible against the engine. This takes skill and finesse. At the top of the hill, John reduces the throttle to 0 and starts coasting. Then he applies the train's dynamic braking system, which reverses the rotation of the traction motors, while keeping a close eye on the amperage flowing through those motors. He also needs to know exactly when to apply the air brakes on longer hills and heavier trains.
Some days I think I got it down. Other days I don't know.
Back at the rail yard,
Go, Jeremy.
fireman Jeremy Simmons and engineer Jim Hamilton prepare to fire up the 70-year-old steam engine for the first time this year.
Have you done the valve oil on top?
Yeah, valve oil is good. And so before we go out for any run, we have to go do our daily inspection, which includes checking all the lubricants.
They've filled the water tender and the fuel tank with thick PS300 fuel oil. When the steam engine is cold, it needs startup help from one of the diesel-electric locomotives. Air from the diesel's compressor will turn the oil in the steam engine from liquid into a fine spray to maximize combustion. It's called atomization.
Once we acquire about 20 pounds of steam on the engine, we're able to shut off the compressor and switch over to steam to atomize the fuel and build a fire.
My train is now starting its first big uphill climb. The steepest parts of the track have a grade of almost 4%, where we gain 1.2 meters of altitude for every 30 meters we move forward, the steepest grade a train can handle without special equipment.
So this section of track is called the Highline section, and in addition to this scenery and these massive drops, it's impressive because of the old wooden trestle bridges we'll go over and the tunnels we'll go through, because those bridges and tunnels are from the late 1800s, which makes it even more impressive. And look at this drop. See why it's called the Highline section. Wow.
It's incredible that it only took 2 years to carve a railroad out of these mountains. Especially because most of the workers were fortune seekers with zero experience building railroads.
Luckily, our railroad foreman knew that he was working with people that had no experience, so instead of using dynamite, he used blasting powder. It was safer to use, slower burning. It shifts rocks out of the way instead of blowing them to pieces like dynamite.
This rugged stretch has claimed lives. In 1917, an avalanche near Slippery Rock knocked an engine right off the cliff, killing the engineer and fireman, a father and son.
So after that, the railroad had a policy of family members weren't allowed on the same engine at the same time.
You can see the front of the train snaking into that tunnel. That's a tunnel that was built in the late 1800s, along with the original part of this line. And right before it, this amazing wooden trestle bridge. Here we go.
This is what it looked like in 1898. They blasted a working ledge into the face of the cliff and built the bridge we just crossed in the dead of winter. The train heads up another hill, nicely stretched out. But suddenly, we've stopped. It can't be to pick up passengers because we're sitting on the edge of a cliff. David, our brakeman, looks puzzled. Turns out John has a very good reason for stopping.
I think I have something on fire.
He's seen smoke coming off an axle. A smoking locomotive is never a good thing. 27 kilometers into our journey on the spectacular White Pass and Yukon route, we've come to a sudden stop on a steep part of the mountain. Our engineer, John, and conductor, Chris, are trying to figure out what's wrong.
He must have smelled something, a gauge goes off, or a bell goes off, and he's not real sure what it is, but it's unusual that we did stop.
I'm not seeing anything right now, Chris. I guess I was looking back and I saw smoke, which is never a good sign, and so I stopped, and there's several things that could smoke. Traction motors can burn up.
Traction motors under high strain can cause a serious electrical fire. Located on the train's 6 axles, the traction motors provide propulsion power to the wheels, using electricity generated by the locomotive's engine. The fast-spinning wire inside the traction motors can break and unwind if the motor is overworked. That happens often on a steep mountain railway. So White Pass mechanics overhaul at least a dozen traction motors every season. They're fixing one right now back at the shop.
We had to replace the traction motor due to it's going to what they call going to ground. It had a short in it.
Mechanics Jackie and John are an efficient team, and an unusual one. They don't just work together, they also live together.
Well, we work up here 8 months out of the year, and then we work for another company down in Washington State
4 months out of the year.
4 months out of the year.
So we're on the road together all the time.
They'll have this locomotive back on the track tomorrow. Up on the mountain, our engineer hasn't found any sign of smoke while the locomotive is stopped. John decides to proceed with caution. Chris, the conductor, keeps a close eye on the axle as the train starts up.
There we go. Did you see anything? No, there was a little bit of smoke coming off the #2 traction motor, but it seems to be clearing up.
For now, it's an unsolved mystery. Could have been a bit of excess grease or oil burning off on the axle. But John's not taking anything for granted.
Well, I'll be wary. I won't be my relaxed, cheerful self.
As our train picks up speed again, we're approaching some of the best-known sights and some of the most tragic parts of White Pass history.
Amidst this incredible landscape and vista, this area below is actually called Dead Horse Gulch, and it's appropriately named for the thousands of animals and horses that died because of abuse and neglect at the hands of the early gold prospectors.
Crossing this gulch also created challenges for the railroad's builders, and it resulted in an engineering wonder.
This is the Cantilever Bridge right here, and we're actually not going to go over it. It was shut down many years ago, but they've kept it here as this incredible historic monument. Look at that.
It was decommissioned in the 1970s because it was too light to carry the heavy haul ore trains of that era. But when it was built back in 1901, it was the tallest structure of its kind in the world. Here's the bridge that replaced it. Not as beautiful, but gets the job done. We're closing in on the White Pass summit. The track foreman has arrived ahead of us.
Motorcar 2021 is in the clear at White Pass.
Brian Thompson gives the morning trains approaching White Pass the all clear. 5 of them altogether. The summit is also the border between the US and Canada, marked by a pair of flags on a hill. Now Brian has another important job to do, a roll-by inspection required by law. He's looking for anything out of the ordinary, mechanical issues, or anything dragging, smoking, or caught up in the running gear. There have been thousands of perfect runs for engineer John Westfall over the past 4 decades. But he had one bad day right here at White Pass in 2014.
The worst day I actually had was about 2 years ago. We got to White Pass and the throw rod of the switch had broken. And instead of going up the main, we went up between the 2 tracks.
The engines plowed into the gravel between the tracks and derailed.
Luckily, we had just minor injuries. It was bad. It could have been really bad.
The throw rod that links the switch lever to the movable track was part of an old switch, the only one left on the line. It's since been replaced, and there have been upgrades to other parts of the line. Even though we've crossed the border, we've still got 13 kilometers to go before we get to the actual Canada Customs checkpoint. Back down at the rail yard, the steam engine is coming alive, firing up for that first critical test run of the season. The black smoke comes from oil. The white stuff is steam.
We now have 50 pounds of steam pressure on, so we're going to cut the air supply off from the locomotive and switch it over to steam so it'll be on its own.
At this stage, the steam engine no longer needs help from the diesel-electric locomotive. There are nervous moments whenever an old machine like this is fired up after a long winter's nap. If any part is weak, any joint loose, or any seal broken, it could cause a rupture, and superheated, high-pressure steam could escape. Jeremy is hoping that cold oil can heat up quickly enough to give them the power required for the test run.
This is the first time we're running it this year, and so the oil's really cold. So right now we can get our boiler pressure up pretty well, but if that oil's not hot enough when we're up on the hill, we won't be able to maintain track speed like we'd like to.
There's a lot riding on this test run. Rail fans are happy to pay a 20% premium for the steam engine. With thousands of tourists paying $160 a ride, that's a big boost for business. But only if everything checks out today. I'm riding the same rails ridden by tens of thousands of fortune seekers more than a century ago. On the White Pass and Yukon route, starting in Skagway, Alaska, and heading toward the Klondike in Canada. We've just crossed an international border.
We're in northern BC, a couple miles inside the Canadian border. And the landscape, very different. Almost right away when we crossed into northern British Columbia, the topography changed.
Trees and plants struggle to survive in this fragile subarctic alpine environment. Another fascinating thing about this spot, the railroad follows an invisible dividing line here. The water on this side of the track drains south to the Pacific Ocean. The water on the other side of the train drains north into the Yukon River.
So we've got Lake Bernard right beside us, and here we are, Fraser, British Columbia.
This is where we'll clear Canadian customs and where our train turns around. Fraser is a tiny outpost that sits between the railroad and the Klondike Highway. This is what the original Canada Customs Office looked like in 1899. But when you arrive here by train today, the border officers come to us.
Morning, everybody. Morning. Has everybody got their passports open and their pictures? And if you've got a Canada visa, could you please find that for us as well?
This must be one of the most unique borders in the country, right?
Well, certainly from a scenery perspective, it is. We're considered an isolated post.
Thank you.
Isolated or not, Trevor and his staff are busy.
Good. How was the train ride?
Awesome.
Better than hiking up with a backpack? Yeah. It's good.
They process almost 300,000 passengers a year here, about half from these trains.
Go Bears.
Time to turn the locomotive around for the trip back down to Skagway. John activates the throw rod to direct the engine onto a parallel track and drives past our carriages to hook up at the other end. He also had another look at that axle, and there's no sign of overheating. Seats are flipped, ready to take on new passengers returning from tour bus excursions inland.
Watch your step going up here.
Meanwhile, much further down the track, Engine 73 is quite a sight on her first test run of the season. A short performance trip, hauling carriages without passengers. Running this 70-year-old locomotive requires the full attention of both engineer and fireman. Jim controls the throttle, the brakes, and the amount of steam powering the engine's cylinders. Jeremy controls the fire by adjusting the volume of oil delivered to the firebox. He also controls the boiler's pressure and water level.
So you're always balancing that. If you can kind of find that lovely happy medium where you've got enough fire and enough water getting in there, then it makes the job real easy.
As they cross the trestle bridge and enter that first tunnel, they're still watching closely for any leaks or unfamiliar sounds. My train will be heading back down the mountain, where we'll be stopped in the middle of nowhere by some intrepid travelers. Our brakeman, David, has a lot of new heads to count. Passengers who boarded in Fraser, BC for our trip back to Skagway. This is a great moment to meet some of them.
So you're from the Caribbean, you're living in Berkeley temporarily, and now you're up in the wilds of Alaska.
Right.
You're quite a globetrotter.
Right.
What do you think of this railway so far?
I think it's beautiful. Natural beauty is amazing.
Yeah.
The snow, the mountains, the glaciers, it's all amazing.
It's a throwback to the old days. You know, it's unbridled nature in a sense, you know, unvarnished. And it's hard to see this anywhere in the world except here. I mean, they built the railroad through nothing and chopped it out, and look what you see.
We're slowing down.
For some reason, it took them forever to stop.
Someone's hitching a ride. It's a group of snowshoers from one of the cruise ships, along with their local guide.
So we got off the train today, and then they have this station where you gear up, put your pants on, snowshoes, and then kind of trek across the backcountry area.
When we booked our cruise, I wanted to make sure that we were doing something that was very Alaska and very Canadian and kind of connected with the Klondike and connected with the history.
The gold rush history, especially.
So it was really important for us to kind of get back into that history, and then we're outdoorsy, so having this train connect with this adventure was a must.
We've passed the summit. A lot of the journey from here will be downhill. So John engages those dynamic brakes,
going dynamics,
reversing the role of the traction motors. Inside the stationary part of the motor, the sequence of rotation of the electromagnetic field changes direction. This forces the rotor, the moving part, to resist against the forward motion of the axle. This process generates huge amounts of power, which could burn up the traction motors in minutes. So excess electricity is fed through a grid and resistors, then released into the air.
So the power they're producing, you can hear that high whine sound. That's they're run through grids, resistors, and blown away as heat.
Right now, John's also getting a little extra help from the back of the train and something called a retainer valve.
We have these retainers here. Sometimes we use them. We're using them right now. Going down the hill, that helps with the braking going down the hill. Keeps our air system up.
When the engineer applies the air brakes, air pressure drops and the brakes can't be used until it builds up again. But on every carriage, there's a retainer valve that holds back a small amount of air to keep the train's brakes engaged while the system regains pressure. Steam engine 73 has pulled onto a loop near Fraser. The same place it turns around on tourist trips. It's conveniently located near a stream where the water tank is topped up. Jim's busy giving the running gear another blast of hard grease to ensure that these high-friction parts of the steam engine never get too hot.
We got one warm bearing here, but it's not critical, it's warm. Other than that, perfect.
Fireman Jeremy is breathing a lot easier now that the cold start is behind him.
could tell that the fuel was pretty cold when we first got started, but right around, I don't know, 10 mile, it started to kind of pick up a bit. Kind of found the sweet spot in there. Even though we were a little worried about how cold it was going to be, it's kind of made up for it now.
And the engineer's verdict?
She ran excellent. We had a great trip, a lot of good repairs done, and we're looking forward to a really good season.
We've just passed the spot where John saw smoke on the trip up. And we've stopped again. This time we're picking up a pair of skiers. And look who it is. Hi. The avalanche guy, Bill Glued, and a buddy. Bill and Denny were working far above the snow line today, at about 1,600 meters above sea level. A few hundred meters higher than we are right now.
So, well, this is probably our final trip up above the tracks, checking the snow for avalanche danger. We've had, 5 days of pretty warm weather now, and sunshine, and the snow has been going through a fairly rapid warm-up, but it's been slow enough that it's been settling in place without too many slides. So we're feeling pretty good.
One less thing to worry about. As White Pass staff race to keep up with what might be the busiest tourist season ever.
All aboard!
It's late morning, and the first trains of the day are almost back in Skagway. Downtown is busy, unrecognizable from a month ago. And White Pass mechanics are in demand all over town. John and Jackie are supposed to be back at the shop, where the work is piling up. But they're also on call at the dock, where they have to inspect every locomotive that returns from the mountain. John goes inside to check oil and water levels, while Jackie does the outside inspection, checking brakes, traction motors, and springs.
We do it in the mornings when we start them up, and we do them in the afternoons before they go back up the mountain.
Then they hurry back to the shop, and some heavy lifting.
All right, give her a go.
Set it up. One of the reconditioned generators is hoisted into place. This locomotive will be back on track next week, while this one is still waiting for its engine to arrive from Seattle. Until then, Keith can't afford any breakdowns.
You really depend on the equipment you have right now. I don't have backup equipment to replace something if it goes down. So once we do get the prime mover, I'll have everybody going on this 24 hours a day.
Soon, steam engine 73 will be hauling its first passengers of the season, 3 days a week. Word's already out that the test run was a big success.
Number 73 is the pride of our fleet. It's a 1947 Baldwin locomotive. We did fire it up today. It is absolutely beautiful. It is a sight to behold.
My journey is almost over.
We want to thank you for riding with us on the White Pass and Yukon Railroad. I hope you enjoyed your excursion today.
You're welcome.
I can't help but envy the staff who get to do this every day.
You ever get tired of being on this train?
No, never. Oh, it's great. I mean, it changes every single day. The river looks different. The plants are different about every 1,000 feet. We go nearly 3,000 feet. You meet different people every day. It's the best job I've ever had.
Over the next 5 months, 400,000 people will feel the thrill of this spectacular railway. I just want to jump on one of those afternoon trains and do it all over again.
What an incredible trip. It was really fascinating for me to ride a train that's evolved so much over almost 120 years. And I think I appreciate now why it means so much to this region and to the people here.
And I also understand why this railroad shares historic civil engineering landmark status with other wonders of the world. This is Scandinavia's king of cargo, one of the fastest freight trains in all of Europe. Its mission? Beat the clock. Pick up and deliver fresh fish before it spoils. A dangerous journey through steep mountains and killer cliffs. Customers around the world are waiting.
Now.
And this train can't afford to be late, no matter what gets in its way.
It's a truly epic trip that cuts through some of the most beautiful but unforgiving terrain on the planet.
It's the North Rail Express. Oslo, Norway, one of Europe's fastest growing capitals. Rich from natural resources and famous for its fantastic fish.
This looks great. What do we have here?
Fresh Atlantic cod.
The fish served in restaurants here in Oslo are caught north of the Arctic Circle, and they arrive here still fresh in less than 2 days. How does that happen?
This incredible freight train is what makes it possible. The North Rail Express. Electric-powered, super efficient, in action 6 days a week, every week of the year.
All these fish have come from the north with our famous North Rail Express.
The train's unique high-tech refrigeration trailers are temperature controlled, with individual thermostats that keep their cargo in perfect shape. The North Rail Express is the kingpin in a hugely successful transport chain that begins way north of Oslo, above the Arctic Circle, with the fishermen.
We are depending on the North Rail Express to bring these fish on the markets.
Whatever the crew catches is delivered to the local packing plant.
So when the boat comes in, the fish goes directly here to this line.
Then the fish are trucked more than 200 kilometers down the coast. From the packing plant in Mure to the train station in Narvik. That's where the North Rail Express takes over. It transports the fish on an epic 2,000-kilometer journey through treacherous mountains via Sweden and onto Oslo, where workers hustle to offload and distribute the precious cargo around the world.
It's so important for us that the train arrive here on time every morning. That's a competition every day, to be on time.
It's a competition Jan Austerheim has to win.
What's the problem?
His bosses at DB Schenker pay him to make sure the Arctic fish arrives in Oslo less than 48 hours after being pulled from the sea.
This can be the train. Yeah. So it's really fresh. Okay.
Yeah, it's very fresh.
Yeah.
The fresher the fish, the more they're worth.
We must work fast to get it out in time.
If we are 1 day delayed, the price for the fish go down with about 10% per day.
It's a little bit stressed.
If the train arrives late in Oslo, it can set off a disastrous chain reaction. The fish is scheduled to be on a specific plane, ship, or ferry within hours. Miss those scheduled departures, and it's a big problem for Jan and his team.
It's so important to be in the market in Europe next morning. If we are delayed, the buyers buy fish from other companies, and then we have lost it.
It's not just about getting the fish out to the world. It's also about turning that train around and making sure it's in perfect running order to keep the supply chain moving. There's a lot to be done before it can head back north for more fish.
We have to de-ice the train to make sure that we won't have any brake failure. And then we have to check the brakes. We have to do the security check to see that nothing sticks out, and then it's off.
The wagons that carry the refrigeration trailers are the backbone of this train. During their journey from the Arctic, they get caked with snow and ice that can jam up the braking system. So the undercarriages are blasted with a glycol and water mix, a process that can only happen here in the south of Norway, because at the other end of the line, it's so cold, even de-icing machinery freezes up. This skeletal framework will soon start looking like a real train when they begin loading the trailers. But first, the wagons need a thorough inspection.
These need to change.
The brakes get extra special attention. They look for problems caused by snow and ice and check for wear and tear that happens during those extreme mountain descents.
When these get too thin, it breaks in the middle, and that's not good.
He's talking about the brake block, much like a brake pad in a car. He removes the damaged part and installs a new one. While this team races to turn the train around, the fishermen up north in Mure are on a special mission.
Now we are heading for the Skrei banks to try to catch some Skrei.
This is the season for Skrei, a highly prized variety of Arctic cod, in great demand as far away as Asia and North America.
The price of the fish is depending on getting it quickly to these markets.
But the season is short, just 2 winter months every year. That's when millions of Skrei return from the Barents Sea, the spawning grounds on the Norwegian coast.
It's a very lot of cod, small spaces, so we get these big catches.
The long-line fishing boat reaches the spawning grounds at sunup.
Oh, we are looking for Skrei between 4 and 8 kilos. It's the most paid fish in the market.
Only full-grown fish are allowed to be caught from small boats like this one, using baited hooks on a long line.
Nice, good food. We have to bring it to the factory as soon as possible to get it loaded on the train so they can bring it on the market as quickly as possible.
Captain Remy's not talking about any old train. The North Rail Express is pulled by powerful electric locomotives. Each Swedish RC4 puts out about 5,000 horsepower, with a top speed of 135 kilometers an hour. These high-tech refrigerated trailers are known as swap bodies, designed to be pulled by a truck and then lifted directly onto flat wagons. The front legs fold up and the wheels fit snugly into wells on the wagon. Each trailer has its own thermostat and enough fuel to allow it to operate independently of the locomotive. Before departure, they need to be washed down and decontaminated from the last fish run. Then they're sent to be refueled. In the control center, Olka Svensson keeps his eye on all the trailers, in the yard and on the rails.
If the refrigerator stops, the goods will be destroyed. We monitor the systems, the computer systems with the GPS positions. It's minute by minute, and we can tell the temperature, speed, position. I see an alarm.
The sensitive monitoring system has detected a problem on one of the trailers that will head north tonight.
Trying to remote reboot the refrigerator and see if the problem will disappear of itself.
But it won't reboot, so a technician has to check it out.
It's alarm 20. It means that the engine is not starting up, it's just cranking. It could be a diesel problem or electric problem.
When the train is traveling at speed, a remote reboot using wireless technology is always the first step.
I have to fix it fast.
If that doesn't work, the faulty trailer is dropped off en route, repaired, and the next train picks it up.
This is the fuel solenoid. This one should pull back and open for the fuel, but this not.
But this trailer can be fixed on site.
This should do it.
Time to turn those truck trailers into a train. 24 of them will be loaded onto wagons for tonight's journey north. During this phase of the operation, it's critical to make sure the trailer's support feet are completely folded up.
I'm just oiling up the support feet before putting it on the train. Because if the feet sticks out, the ground will grab them and rip them off.
Everything has to be tucked in just right for the trailer to fit in its special trough.
This is a kingpin plate, and the kingpin is under the cargo, so it has to fit in the hole to lock it.
Each trailer is matched to a specific wagon, then lifted before it's lowered into position. At the other end of the train, Christer Utnes, the head of the loading crew, is having trouble with the very last trailer.
We have bad time, and like 15 minutes left before leaving, so quite short on time.
The trailer is not locking down properly, and the train is supposed to leave in 10 minutes.
Yeah.
It's so important to be on time when you start the trip from the terminal. 5 minutes delay from the terminal, it can be 2 or 3 hours delay at the end.
If the North Rail Express misses its scheduled departure time, it can't pass other trains on the single track. It will have to pull over onto a siding and let others by.
It's heavy traffic on this line. We are driving up to the north and down again. There is only one track.
The train can't leave until everything is secure. And a delay is bad for the fish and bad for business. Minutes before the North Rail Express is scheduled to depart Oslo for its journey north, one of the trailers isn't fitting into position on top of its wagon.
Hurry up.
The lockdown mechanism on the wagon is supposed to lie flat.
That cannot be in upright position when we have the trailers on, so we have to put it down again.
When the part is upright, it prevents the trailer from locking in. Christer has to get underneath the trailer to adjust the misaligned part. Now the trailer and wagon connect.
That was the last unit and we made it. And it's 10 minutes to departure. So, well done today.
The North Rail Express pulls out of Oslo's Alnabru station at 9:30 p.m. It's not leaving empty. Whenever this train heads north, it's always filled with supplies for remote Arctic communities. Medicine, fresh produce, even new cars. It's a 27-hour journey. Crossing a big chunk of Sweden overnight, then traveling north to Kiruna, into the mountains, and the final treacherous section to Narvik. Hey guys!
Hey!
How you doing?
All right, we're fine.
I've traveled ahead to have a look at that stretch of track in daylight, hitching a ride on the maintenance train.
Oh, be careful with the steps.
Okay.
Maybe they can be a little bit slippery.
This is great.
Come on board.
Thank you.
The landscape up here is beautiful, but unforgiving.
Look at that. It's incredible. Going up pretty high into the mountains.
Yeah, for every 10 kilometers, we go up 120 meters.
The track climbs high above the fjords, clinging to the mountainsides. And where it's too precarious, there are tunnels.
How difficult was this to build back in the 1800s?
It was very difficult because they have to use hand methods to build it.
Right.
So it's about 20 tunnels, and 18 of them is hand drilling.
So what's this we're going under, because it's not a full tunnel?
This is a snow shed. We have a lot of problems with snow in the winter here.
Snow sheds protect the tracks and trains from falling rock and snow. So the railroad doesn't have to be shut down for track clearing after every avalanche.
So avalanches?
Avalanches, and also snow that's blowing in the wind and stopping the track.
How common are avalanches here?
It's about 5 to 10 avalanches every year.
Every year?
Yeah.
The northbound train is approaching the halfway point in its 27-hour journey. At this time of day, Captain Remy and his crew are delivering their catch to the packing plant up on the Arctic coast.
The catch is quite good. We have 1 ton of excellent scray.
This is peak season. We are in the middle of scray fishing. The turnover for our factory is around $75 million a year. 80% of this is done now in the winter season.
Trina is in charge of the packing plant. Her top priority, making sure everyone meets deadlines.
Spray packing will start right away. They finish in the...
On the other radar?
In the other side, yes.
Okay, because
right away.
It's a critical point to reach the North Rail Express every day on time. Well, if we miss the cutoff, we take the risk then that the customer will say, no, we don't want this fish. Or we can take it, but it's late, so we want a cheaper price.
It has to be cleaned and packed on ice within 12 hours of being caught. Even the local kids get in on the action, doing what their ancestors did, cutting out cod tongues, a delicacy in many parts of the world.
I love doing this. Kids can make good money by doing this.
If they work fast, they can make up to $5,000 every season. But only if the cod tongues and the rest of the fish get to Narvik and the North Rail Express in time. Back on the maintenance train, I'm learning how this great mountain railroad began, and it had nothing to do with fish.
This is a part of the iron ore line to Kiruna. It's 169 kilometers from Narvik station to Kiruna.
Every day, about 15 trains loaded with iron ore travel this treacherous route from Kiruna to Narvik. That adds up to 76,000 tons of ore a year.
And it's heavy traffic from the iron ore trains. So we do a lot of maintenance on this line.
The line was built between 1898 and 1902, so steam trains could haul the heavy cargo over the mountains and down to the coast at Narvik. But importing coal for steam was expensive, so the region's huge water supply was put to use to electrify the track. Workers erected steel masts along the track and installed almost 200 kilometers of overhead wires between Narvik and Kiruna creating the catenary that powers the trains. 100 years later, there are so many mining tunnels running underneath Kiruna that the town is in danger of caving in on itself. So, people here are taking extreme measures to make sure the town survives.
One of the first projects the town undertook was moving the rail line. And over the next 20 years, they'll be moving the entire town, a couple of miles that way.
This town and Sweden's iron ore industry depend on the railroad. And so does Norway's Arctic fishery. The North Rail Express is still on schedule for its arrival in Narvik tonight. Meanwhile, at the packing plant, Trina's still racing to get today's load of fish ready for transport.
This fish needs to go through the factory very fast, in boxes, on the truck, and reach the North Rail Express.
Skray earns top dollar because it's meatier and more compact than regular cod. Fishmongers and restaurateurs seek it out because their customers love it.
This is great quality. This is a great quality. You see, this is the best quality of the fish. It depends of the color of the skin, depends of the color of the meat.
Is the truck ready for Macedonia?
Yes.
Where? Is it finished? Missing something or all good?
Three pallets.
3 pallets missing.
Yeah, we need 3 pallets more.
The last truck should be on the road by now to reach the train on time. But it can't leave without the missing pallets.
But the time now is... Where is the driver? Where is the driver? Oh, klart over färd?
Ja. Men du manglar 3 pallar. Yeah, he should have been gone for like maybe 20-25 minutes ago.
It's a 4-hour drive at the best of times.
They are coming.
They need to hurry. You know, we are not reaching the train now.
If they miss tonight's train, the value of today's catch will take a dive.
We need the last pallets like now because the truck needs to leave. Tell them to hurry, please. Now.
The North Rail Express is well into its journey, on its way to pick up a big load of fish on the Arctic coast. Meanwhile, up north, one of the trucks that's supposed to be hauling the fish to the train is running late.
They need to hurry, you know?
An important order from this morning's fish haul has gone missing. Trina and her crew have to find it and load it into the temperature-controlled transport trailer.
This is for an important customer in Barcelona. So we are waiting now for 3 more pallets to fill the truck. In this office? Yeah. Okay.
They finally locate the pallets among hundreds of others.
All good? So now we have to get it out of here so the driver can reach the train in Narvik.
The driver now has a hazardous, icy journey to the train station.
Because if we don't reach the North Rail Express, the fish will lose thousands of dollars in value.
We have under 4 hours to get to Narvik. It's always time pressure.
From the fishing plant, the loaded trucks have to navigate over 200 kilometers of winding highway carved into the rocky coastline before they reach the train in Narvik.
It's not easy to drive when it's snowing because suddenly everything gets white and you have to figure out where the road is.
Bad weather isn't the only hazard.
This time of year, we have to be very careful about the moose.
Wildlife on winter roads can be a showstopper.
Possibly I don't reach the train, and then they don't hold it for me, so then the fish is not going by train.
While Eskil keeps his eyes on the road ahead, the engineer for tonight's southbound train has started his shift in Narvik. Rickard will drive a pair of fresh locomotives and hook them up to the wagons arriving with the northbound train. He'll be responsible for that challenging stretch from here to Kiruna that I saw earlier from the maintenance train. But Rickard will be driving in the dark.
So Rickard, where are we now?
We are in the locomotive stable, where we're de-icing the locomotives before departure.
Okay, so that they sit here and all the ice melts off?
Yep.
And is this the actual locomotive that will be on the journey tonight?
Yes, this is.
This is like your office.
My office, the best.
On this journey from Narvik to Kiruna, what are the biggest challenges that you face as the engineer?
The biggest challenge is going from sea level up to the mountains. It's pretty hard. Need a lot of power.
So I'm sure you always hope that it's a smooth ride and that nothing goes wrong, but if something does go wrong, for instance with the electricity on the route up in the mountains, what do you do? I mean, how do you fix that in those conditions?
I have warm clothes, I have food, I have water with me.
Right.
Because I never know how long time it's going to take before I can retake my route. If you have avalanches and stuff like that, they can't get through. So we can be there for 10, 15 hours.
It's a tough day at the office.
Yeah, that's a tough day.
Yeah.
Out on the road, Eskil and his truckload of fish have reached the outskirts of Narvik. Other trucks have already arrived at the rail yard. Their cargo trailers ready to be swapped with the ones on the incoming train.
And here it comes, the northbound North Rail Express, arriving after an almost 2,000-kilometer journey from Oslo. It's filled with supplies for Narvik and the region here, and soon it'll be loaded up with fish and then head southbound, destined back again for Oslo.
The train is scheduled to leave in less than an hour. It's disassembled quickly, and the supplies for remote Arctic communities offloaded. Including those new cars. Once the incoming cargo trailers have been lifted off, the snow that accumulated on the wagons during the 2,000-kilometer trip has to be removed.
It's very important work that he's doing, getting rid of that ice and snow. It's so the wheels of the truck containers can sit where they should in the wells. All right. Oh, it's really caked on. So if you don't get everything with the machine, you gotta get in and get your hands dirty, right?
Yeah, it's very important for safety reasons. We have to get the wheels all the way down.
So how are we looking? Is it all right?
I think we're good.
Yeah, thanks for showing me what you do.
Once cleared, the wagons are matched up with the cargo trailers holding this morning's catch. Rickard is on the job.
So not long until departure, a lot to do, right?
Yeah. Now it's a busy time.
He oversees the loading and inspects every wagon.
Have to check the brakes, and that's everything. The wheels are okay, so it's safe to go over the mountains.
He also needs to make sure the 26 fish-filled trailers, weighing close to 1,000 tons, are locked down and ready to climb up and over the mountain range.
It's a dangerous route. It's a lot of things can happen. It can be ice, and it can be really slippery, so we need the power to get up.
Time to roll out the locomotives. During high season, they often need 2 of these RC4s to haul the extra heavy loads of fish. Rickard hooks them up to the rest of the train. The southbound train is right on schedule for departure. And then...
Oh, what's happened? Oh, up in the mountains? Oh,
somewhere on Rickard's route, there's a power line down. This train runs on electricity, so it's not going anywhere. The North Rail Express has pulled off a quick turnaround. Its trailers locked and loaded with fresh fish for the long trip south, destined for customers around the world.
Hey, this is Rickard.
But Rickard, the locomotive engineer, has just found out the power is down.
Problems up in the mountains about one of the pillars that keep up the overhead line have been damaged. How long time will it take? Okay. If something gets damaged, the whole system fails.
A power failure on the electric rail line is trouble.
So we're going to be a few hours late, the departure. You make me a call when it's time to go? Ah, nice. Thank you.
The North Rail Express runs on an electrified rail system. The power is supplied by the overhead lines suspended above the tracks and fed to the locomotive through a rooftop collector called a pantograph. An electric locomotive is basically a massive mobile transformer. It turns the 15 kilovolt AC current from the overhead line into a lower voltage DC current that powers the 4 traction motors that drive the engine's wheels. But when there's no current to feed it, the locomotive is powerless. Rickard finds out that weather damage to the catenary line has caused the power failure in the mountains just outside Narvik.
It's a very difficult remote place to get to. We have no other way around, so we have to wait until they fix the problems.
Luckily, the insulated refrigeration trailers can keep the fish at a stable temperature because they have their own generators. Otherwise, in this minus 35-degree cold, the fish would freeze and their freshness would be compromised. Rickard waits 3.5 hours and finally gets the go-ahead.
Yep, det blir bra det. Tack så mycket. Hej.
But because the North Rail Express is leaving behind schedule, it's lost its privilege to pass other trains. Even before it's out of the rail yard, it has to pull over on a sideline to let others go ahead.
This is one of the Arctic Rail Expresses, another sort of train that's going from Oslo to Narvik. So now I got the signal, all clear.
The North Rail Express begins its climb up the steep mountain range that separates Norway from Sweden.
Now we have to try to build up some speed.
The first grade is the steepest, close to 3%. A tough haul with a 1,250-ton load.
It's working hard.
The RC4 electric locomotives provide a maximum of 3,600 kilowatts of power, or 5,000 horsepower, to the 4 traction motors that drive the axles that turn the wheels.
I can actually see in this how the engine's working, 4 engines.
Our train needs max power to pull that load from sea level up to the top of the coastal mountain range.
So I have maximum power on.
But is it enough? On this 3% incline, with gravity working against the locomotive, the 1,250 tons becomes the equivalent of hauling more than 1,600 tons. That's like adding 9 more trailers full of fish.
Just nu nu fick jag till slut fäste, så nu är jag uppe. Nu börjar jag bygga upp lite hastighet igen. The controller was asking us if we were still alive because we're building up speed too slow. But finally, we're getting up some speed.
Rickard is even getting green lights to pass some of the oncoming freights.
So finally we're building up some speed. We are up to 50 kilometers an hour now. 70, that's maximum speed on this part of the track.
Starting at sea level in Narvik, Norway, the train climbs 40 kilometers to the top of the mountain at 523 meters above sea level. Then it's a steep descent and more jaw-dropping climbs to Kiruna in Sweden.
And this ore line that we have driving on now is one of our most difficult routes because of all the snow and the harsh weather up in the mountains. It's pretty risky.
Risky because the closer he gets to the peak, the heavier the winds and snow. The North Rail Express has tackled the riskiest part of its route to Oslo. Through the mountains and made it to the top. The border between Norway and Sweden is just ahead, inside this tunnel.
Now we're passing the Norwegian-Swedish border and are in Sweden at this moment. And now we are on the top of the mountain.
The next stretch will be a steep descent on the way to Kiruna, where the North Rail Express will make its one stop to pick up more fish. And Rickard will end his shift.
I'm taking on the brakes because we're going downhill now.
Gravity may have challenged the train on the way up, but it's about to do it a favor on the way down. Our electric locomotive uses energy from the overhead lines to power the traction motors that turn the wheels. But when going downhill, that process is reversed. The train's downhill momentum turns the wheels, and the traction motors become generators that produce electricity. That electricity then gets fed back into the overhead lines and used by other trains. A power outage caused Rickard to leave Narvik behind schedule.
The consequence of that time loss will be delayed cargo for the trucks waiting.
He's hoping to make up time, confident that this train has been serviced by the best in the business. At this maintenance center in Luleå, Sweden, where skilled professionals ensure the trains are in good working order. Today, they're checking the contact strips, which help conduct current from the overhead lines to the locomotive. Those strips can get damaged when ice and snow build up on the lines, causing arcing and sparks.
Yeah, they're looking on the carbon strips, looking for cracks, look at the thickness, look if the material is wearing out.
Ingen sprickbildning.
The conductors are cleaned and their thickness measured. If the rails are uneven, they're filed down.
Ja, nu tar jag avsyna här, kolla alla gummin så att det är tätt, inga sprickor på slangar.
If they find major cracks, they replace the whole carbon strip to make sure the locomotives never lose power in the middle of nowhere.
Yeah. With cracks, the power transmission doesn't work.
The undercarriage of the locomotive also takes quite a beating from rough terrain and winter weather.
Underneath is a lot of ice gets stuck there and affects the brakes, affects the wheels, so we get flats and other damage on the wheels, so we have to get them to lathe.
Severe ice jams in the brakes can prevent the wheels from turning, making them skid along the tracks, creating flat spots on their steel surface. If a flat is found, it's sent to the lathe, where the flat is ground away and the wheel rounded out.
Och det är sånt här man upptäcker vid vinterservice, tillsyn och översyn. Det är till för att man ska upptäcka såna här skador i tid, så man kan åtgärda dem.
And if the surface of the wheel is too damaged, the entire wheel set is taken off and replaced. "60 kilometers to go before Rickard hits Kiruna, where the North Rail Express will pick up 2 more trailers of fish. And where another locomotive engineer will take over, the second of 7 engineers on this journey.
He should be coming in any second now.
Rebecca has been waiting, and now after a long delay is finally on her way to the train yard.
I'll be driving down to Boden and the sun will probably be up way before that, but It should have been here, obviously, 3 hours ago, so.
The 2 additional trailers have already been loaded. Now they're shunted into position, ready for hookup when the train arrives.
When we get to Kiruna, we only have a few minutes to switch drivers and keep on going because we can't lose any more time.
When the North Rail Express pulls to a stop, 3.5 hours behind schedule, it's almost 6 in the morning.
We arrive.
Time to switch engineers.
We have to do the switches. That's because we're only allowed to work several hours because we have to be alert. Det är bara att ta över, det går bra. Jajamensan. Ja, hej då. Because the North Rail Express is just what it says, it's an express line. We switch drivers, so we have to wait and take breaks during the trip, and that will be a long, long journey for the fish.
After a 10-minute stop, the train is on its way. The North Rail Express departs Kiruna with the added weight of 2 more trailers. From here, it should be a straight run to Oslo, its final destination. There's still 1,700 kilometers to go. And another 5 drivers after Rebecca's shift ends. There's no way this train can make up for the delay, even at maximum speed. The fish will arrive late. The trucks, ferries, and flights scheduled to deliver the precious cargo to local and global markets won't wait. The North Rail Express has made it through the most challenging stretch of its 2,000-kilometer trip back to Oslo. As it moves out of the mountains and Arctic wilderness, it picks up speed, trying to gain back some of the lost time. The third of 7 engineers takes her turn at the controls. Shift changes are quick, always less than 10 minutes. At the distribution hub in Oslo, with the train still hours away, manager Gøran Gulbrandsen gets a heads up.
The train was delayed from Narvik. The customers are going to be very angry.
Customers from Tokyo to Barcelona who have very low tolerance for tardiness.
We have to inform the customers that it's going to be late, and the drivers have to also get the information that they have to start later to drive, and many problems we have to solve.
Gøran's team has to alert the truckers scheduled to drive the fish to airports, ferry docks, and destinations all over Europe.
Everything is connected by the train and the ferry. When the train is coming, we can load the trucks. So when it's 3 hours delayed, that means that we are not reaching the ferry.
He has to work out a whole new distribution plan and schedule before the train arrives. The North Rail Express finally rolls in at 6:30 a.m., 30 hours after it left Narvik 2 nights ago. Now it's go time at Oslo's Alnabru terminal.
The fish is here. We are starting building new load for the trucks to Europe.
The distribution team hustles to minimize the domino effect caused by the delay. Rising to this kind of challenge is what it's all about for Jan Osterheim.
We have lots of problems that are working against us, but if we succeeded with all these challenges, that's my way to a success.
It's a rush to get everything sorted and on its way. The trucks are lined up and ready to go as soon as they're loaded. The distribution team has managed to rebook all flights and ferries.
I want to start new round trips, more capacity. It will be one of the biggest export industry from Norway in the future.
In just a few hours, the North Rail Express will be turned around to start its run all over again.
It's amazing to think about all of that fish being caught and loaded on the train up in these small, remote, but thriving Arctic communities. That's a big part of the North Rail Express story, because from here, this fish is shipped all over Europe and the world, maybe even to your plate. It truly is a mighty train.
A cross-continental odyssey aboard the pride of Australia.
Look at the train, it's amazing.
Tackling a land that's wild and harsh.
It's been fighting its way across the outback for almost 100 years. Sometimes, the outback wins.
We're in the middle of nowhere. If we break down, we're it.
Born in the dangerous days of steam.
A boiler like this could be a bomb.
Thriving today as a diesel-powered streamliner.
Nothing is foolproof.
The longest passenger train anywhere.
It's one of the most famous trains on Earth.
This is the Ghan. The Aussie legend closes in on Adelaide, South Australia. Home base for the Ghan. And the end of the line for another load of awestruck travelers.
It's my first time on the train, and I love the landscape.
A 3,000-kilometer journey through the wild heart of Australia, from top to bottom of the continent, crossing 5 climate zones and 2 deserts, where temperatures can hit 60 degrees Celsius. An adventure for foreigners and Aussies alike.
Country, it just changes all the time. Every tree is different.
I can't wait to experience it for myself. And I'm not the only one. The Ghan is so popular they have to keep adding carriages. It stretches out for more than 1 kilometer, so it doesn't exactly stop on a dime.
To make it stop is not difficult. To make it stop where you want is a lot harder.
Hi Dave, just checked with train control. Train's coming in about 30 minutes, so we just come down and set up.
The Ghan's only half an hour away, so the operations manager in Adelaide coordinates which tracks he'll need.
Before we split today, I've got to check with ARTC to make sure that we're clear of the main line.
The trip from Darwin in the north to Parkland's rail terminal in Adelaide has taken 3 days and 2 nights.
Roger, red line.
In 48 hours, the Ghan will head back up to Darwin. That's the trip I'll be taking.
We're going to go down. I'm going to stop the train down the south end, and then we'll send the loco back to you to bring the second section in.
The train's so long they have to split it across 3 platforms, and they have to do it quickly.
We've already got freight trains lining up waiting for us to get in clear, so if we don't come far enough into our terminal, the back of the train's going to be hanging out on the main line and blocking the whole network.
Before the passengers can disembark, the first part of the train is split up using shunting locomotives just outside the terminal. The first section, 16 cars long, is moved on to platform 2. Then the second section, 25 cars long, goes on to platform 1. Finally, the section at platform 1 is split in half again and shunted over to platform number 3 for maintenance and cleaning.
First section of the train is now in position. We've got its authority to uncouple. In the distance, we're pulling in the second section of the Ghan. Absolutely critical that we come all the way down with the second section.
Platform number 1, please stand well clear behind the yellow line for the arrival of the second section of the Ghan.
For 1.
Roger, then, thank you.
Now that all 3 sections of the train are parked at a platform, the journey is over for these travelers.
Hi, folks. Hope you've enjoyed the journey.
The hefty beasts that pull the Ghan are diesel-electric locomotives. 22 meters long with a 4,000 horsepower output. Their top speed is 115 kilometers an hour. and it takes 2 of them to haul all 2,156 tons of the Ghan across Australia. The locomotives go for regular maintenance overhauls in Melbourne. Keeping the Ghan safe and trouble-free is what the guys at the UGL maintenance facility live for.
This is what we're here for. We're here to fault find these things. We test them, try and get them to break, and then we fix them. Let's do a self-test first.
Today, they're performing a load test. Run the engine to its max and see if anything breaks.
So what we're doing here, we're loading the engine to full potential.
Aaron and technician Joel Parker push the engine as high as possible, up to 3,000 kilowatts, to be sure it can sustain maximum horsepower.
It can get pretty noisy, I think up to about 96 decibels at full revs, so the neighbours, they don't really appreciate it.
That's earbleed territory, so they do their test inside this soundproof cell, equipped with noise-absorbing baffles.
Once we get to notch 8, we should see about 3,100 kilowatts.
But when the engine hits 1,000 revolutions per minute, there's a problem. The engine can't hold full horsepower.
That's it.
We're gonna need a multimeter for the panel though.
Joel and Aaron have to figure it out before they can send the locomotive back out on the rails.
The fuses look all right.
In the cabin, they run a computer diagnostic on the radiator fans and discover one of them isn't working at full speed.
It means that we're going to have to rectify the red fan fault before we can send it back out in traffic, because if it's not working correctly, it's not going to run the Ghan and the passengers are going to be stranded at some point in time.
Without these guys, a snag could have become a major issue. Sunday morning, back at the station in Adelaide. 6:45 a.m. Departure day for the northbound journey.
It's like bringing half a house to work for me.
Deb Munn runs this hotel on wheels.
Can you just take those inside, please, Francis? Thanks. We've got 55 crew on board. We're all colour coordinated with the areas that they work in. Good morning, Christian.
Have I got 2 bags?
You sure have. You've got all the radios in that one and all your other stuff in that one.
From housekeeping to dining to passenger excursions.
This has all that information about our guests on.
Deb is the boss.
I am. Look at the train. It's amazing. Scary, but amazing.
The whole terminal kicks into high gear.
I end up walking the train probably 4 times. I've only been here 3 weeks. I've already lost a size in my jeans, so it's very full on.
An army of service workers must strip the linen from the 350 beds.
The linen is clear.
Scrub down all 44 carriages and 6 kitchens and restock 5 lounges.
It's flat out. We've got all our staff in. We're using everything we have available and we're stretched as it is because we only have a certain amount of time to service it on the platform.
By 10 a.m., travelers have started to arrive at the terminal. And I make sure I'm one of the first to check in for the adventure ahead of us.
Hey, how are you?
I'm very excited. How are you doing?
Good, thank you.
Great.
That's on platform number 1.
Great.
Okay.
We usually get about 350 customers today, so that's about 380 to 400 bags.
It's not just people and bags that are being loaded today. Some passengers have paid extra to bring vehicles along. 650 to 1,300 Australian dollars, so they can explore on their own after the train trip.
The closer it gets to departure, every second becomes critical. So we've got a 12:15 departure, which is not negotiable.
Time to reassemble the train. Maintenance worker Darren Barr disconnects a coach that's been moved onto a giant turntable.
The coach has to be turned 180 degrees because the doors for passengers were opening on the incorrect end.
A turntable is a short section of track mounted on a bridge. The bridge can rotate to match the carriage up with any number of tracks surrounding it.
3 feet, red light.
Once that turntable maneuver is complete, the carriage gets a final makeover. It takes some gymnastics to finish off a top bunk. Overseeing this cruise ship on rails is quite a challenge.
But she's given me half, thank you. Thanks, Faye.
Especially while the Ghan is still split up into 3 sections.
You're right to go, love.
So Deb consults with Dennis to figure out which carriages are on which platform.
South section is on platform 2.
Yeah, so that's platinum, white and red, yep.
We have got a small weld job we've got to do between the south end of the sit-up and the north end of the power band.
During their safety check, the crew discovered something that will slow down preparations for departure.
Red light. Pins up, you're right to head south. Even though we've been well organised all since Friday, unfortunately this morning we've now got a weld job on one of the carriages. The problem we've got is that it's inconvenienced the on-train staff because now we've lost power for this section of the train.
They've spotted a metal tear on the frame on the walkway outside the baggage car. It could pull apart in transit.
There we go.
It's a race to make it right. The Ghan and its 350 new passengers are supposed to leave in 15 minutes. My epic Australian adventure on the mighty Ghan starts today.
We're still missing a few, are we? All right.
Train manager Deb Munn hustles to marshal her small army of staff.
Just come here, Christian, Sonia, quickly.
She's trying to work around an unexpected snag.
Your section will not be shunted until we depart, but there is some welding work to be done over there, okay?
Operations to train manager receiving, Deb.
I'm receiving, go ahead, over.
The welding's progressing, we'll only another few more minutes.
Down in the rail yard, welders have been racing to fix a tear on the metal walkway between a carriage and a baggage car. A must-do repair to prevent trouble in the remote outback.
Weld has been completed. We're now happy that everything's okay. This is going to be enabled us to get up to Darwin and back, and it's good for another 50,000 Ks.
Dennis, the train operations boss, signs off on the fix.
Red light.
No questions? All right, let's do it.
Time to board the first section of the train.
Hi there, folks. Do you know which carriage you're travelling in?
Again to Darwin and Alice Springs on platform 2. We'll be departing in 15 minutes.
As soon as we're all aboard in this section,
Passengers on platform number 2.
we move to platform 2 to connect with another set of carriages and passengers. Finally, the 2 locomotives and car carrier can back in and hook us all up. We're ready to roll. Dennis's job is done.
Awesome.
When you get back Friday.
All right. In one piece, hopefully. All right, see ya. This is my train now. All kilometre long of it. Have a nice week. We're leaving Adelaide in southern Australia and heading north for our 3-day journey. We'll stop in Port Augusta, then head to the tiny outback town of Marla, up through the desert center and Alice Springs. On to Catherine and its ancient gorge, till we end at our final destination at the top of Australia in the tropical town of Darwin. So much to see over the next few days. But first, my host, Campbell Parker, is going to show me my room.
Ah, this is me.
Absolutely, this is you.
Oh, it's a great room. Everything is like really optimally laid out.
Yeah,
Love
exactly.
You got my
right.
luggage.
Yeah,
already
already got your luggage here as well. There's plenty of space to store all your bits and pieces. So if you just take a look in the closet here, you can hang your clothes and everything like that. There's a safe in there too.
Okay, bed.
That's
Is this the
exactly
bed?
right. No, this isn't a bed, of course. Well, mind you, this is one bed, so this folds down into a bed. But this one on top jumps down like this. So
great.
There you are. So there's a reading light up there for you as well. Plenty of space.
Looks
and
comfy?
It's comfy and it's safe. The rail comes up as well, so that's good.
That's great.
And then if I just go like this, pop it back like this, so.
And my own bathroom, or do I share a
Oh,
bathroom?
no, you don't share a bathroom. You've got your own bathroom
it's
here,
here.
which is good. So if we just go like this, the shower's over there, the toilet's there, the faucet, the shower curtain here, that comes all the way across, all the way around, so it doesn't get your bathroom wet.
That's perfect.
Yeah,
All
it's
right.
ideal.
Well, thanks, man.
Not a problem at all.
Everything's so user-friendly. But it takes a lot to keep this hotel on wheels running smoothly, starting with many types of rail cars. 3 separate carriages supply electricity. Each has 3 electrical generators, individually powered by a 230 horsepower diesel engine. 5 crew cars are distributed throughout the train, and a separate luggage car gives us more room to move around. 18 carriages provide gold service. Twin rooms like mine with ensuite bathroom, starting at 2,200 Australian dollars per person. There are also single rooms with shared bathroom, starting around $2,000. Gold service gets you access to 4 bars and 4 dining cars. If that isn't luxury enough, there's Platinum Class, 3 carriages where cabins have comfy double beds, starting at $3,300 each. Riding Platinum also gets you into an exclusive lounge and dining car. We're just a couple of hours outside of Adelaide, and the terrain is already beginning to change. We're passing through the Flinders Mountain Range, stretching more than 400 kilometers across South Australia. 2 hours further up the track, we're traveling into more recent history at Port Augusta.
Driver in R75, train manager, you're receiving over.
And 4.
A couple of extra passengers will be boarding here.
And you've got a good 4 to go now, 4 more. Just bear with us, we've got to do 2 stops. Yeah, wait there, love.
Deb guides the locomotive driver into the station, counting him down by carriages.
And 3 now.
She has to be his eyes because the train is just too long for him to catch it all in his mirrors.
And 2 more. Oh, perfect stop. Red light.
Roger, red light.
So we're about 4 hours into our trip, and this is Port Augusta. It's by no means a major stop on the journey, but it's a place with a lot of historic significance.
The Ghan was born right here a century and a half ago. This stunning antique locomotive is the original steam engine number 25. Teams of volunteers spent tens of thousands of hours restoring it. Now it hauls passengers a couple of times a month on day trips out of Port Augusta. The old engine is brought to life first thing in the morning by fireman Jeremy Brown.
What we like to do with an old girl is start her nice and slowly so the metal doesn't expand too quickly. So it takes about 3 to 4 hours to build the steam up.
Steam locomotives, I guess, one of the reasons why we like and playing with them, as it were. There's something very raw and elemental about working with steam and fire and water.
David Hia has been crazy about trains ever since he can remember. When he was 23, he became the youngest steam engine driver in all of Australia.
I guess there's something very special about getting to operate this sort of gear in the 21st century. And certainly there's a lot of romance with the old Ghan and the Ghan story, so.
The restored railway is called the Peachy Reachy, after one of the mountain passes it goes through. It was the first stage of the original railway that was supposed to link southern Australia with the northern edge of the continent. Part of that railroad history is kept alive by brakeman Philip Mellors.
Okay, so I'm indicating to the driver either to go forwards or in reverse.
Phil communicates with the driver using the dying art of hand signaling. 100 years ago, it was a common railroad language.
We've got about 6 inches to go, so we're just giving an indication to the driver just to ease it back onto the coupling. Arms straight, we're stopped.
So we're currently doing our safety check of the train.
The crew has to be hyper vigilant with this old machinery.
Handbrake is on.
So David performs a thorough inspection before any passengers board.
So we're paying particular attention to make sure that everything's coupled up properly, but particularly that our brake blocks are in good condition, because a train like this with the engine weighs about 250 tonne, and we like to make sure that we're able to stop it when we're coming down the hill.
As if my Aussie adventure on the new Ghan isn't enough of a thrill, I'll also take a short ride on the old train to experience what it felt like a century ago. I'm getting the chance of a lifetime to take a short run on Australia's original Ghan. Brakeman Phil Mellors fills me in on the history.
This car we're in now, right at the back, it's the caboose, but it's also basically your home for a lot of the journey, right?
It's called the Special Services car, which comprises a nice observation area, sleeping compartments, dining room, kitchen and so on.
This forerunner of today's Ghan service was a pioneering line designed to open up the vast outback for the cattle and coal mining industries. Its route was shorter than the modern-day one. It started in Port Augusta with a stop in Quorn, then ran 1,200 kilometers to Alice Springs in the middle of the continent. The dream was to lay track all the way to Darwin in the north, but it didn't happen in that era. To really step back in time, Phil shows me the staff quarters.
So this feels a little bit like a passenger compartment. We've got nice seating and everything, but at the same time I see an inspection panel, control knobs. So who actually sat in here?
So this was the sleeping quarters for the cook and the car attendant.
Okay.
So this is currently made up as a seat. We'll convert into a bed. They had a sink with hot and cold running water. And then they had a call system. They could actually buzz, the passengers could buzz the staff, and all the lighting controls for the carriage.
Just imagine what it was like for the guys up in the locomotive, operating this belching beast.
The fireman's got his work cut out for him because we're climbing on a 1 in 60 gradient, so for every 60 units of measurement we go forward, we're climbing one. And it doesn't seem like a lot, but when the elevation distance is something like 1,200 feet and the engine's hauling the best part of 200 tonnes up that, there's a lot of power required to do that.
So Jeremy Brown has to shovel an unbelievable 2 tons of coal just to keep the engine going on this journey. And David? Well, he can't take his eyes off the boiler.
I guess one thing in the back of our mind all the time when we're working with these locomotives is the boiler contains so much energy. We've got several 100,000 gallons of water in there at very high temperature and very high pressure. Being able to harness and control that safely is probably one of the biggest responsibilities of the crew working the engine. In the wrong hands, a boiler like this could be a bomb.
That's exactly what happened in 1914. A small flaw in the steam engine's firebox blew a locomotive apart. The original Ghan faced other hazards too. It was often sideswiped by bushfires, flash floods, and the extreme environment. So many challenges that the line north to Darwin couldn't get built.
When it rained in the outback, dry riverbeds will then become raging torrents, and that could actually cause washaways and significant delays along the line.
In 1980, the Ghan was finally rerouted. An updated track was installed, originating farther south in Adelaide. Then in 2004, the northern part of the dream came true. The Ghan was connected all the way to Darwin. Back on the much safer 21st century Ghan, we've left Port Augusta, and the crew is getting ready to serve up some national pride.
And ladies and gentlemen, good evening once again. Time on board the Ghan is now 20 minutes to 6, and our dinner service will be commencing very shortly.
All 6 kitchens aboard are run by top-notch chefs who cook up more than 500,000 meals a year, using the finest of their country's ingredients.
As an Australian, how do you feel knowing that you're giving people a real kind of taste of Australia, not just the landscape, but the food?
Well, yeah, it's really good actually, because every piece of produce we have is sourced regionally from that area.
Yeah.
So, for instance, this lamb we have on the grill here, that's Kangaroo Islands.
All right, well, let's get back to work. Thanks,
No
man.
worries, thanks, mate.
Okay, thanks.
How you looking, fellas? All right.
Sourcing and storing those prized ingredients is the job of the food and beverage manager back in Adelaide, Bradley Kirkman.
All of our cool room produce sits in here. About $75,000 worth of food we picked today.
Refrigeration is critical on this train. It has to be meticulously calibrated to offset the extremes of desert temperatures.
I like to just come through and just make a quick observation of the freshness of the produce. We need to make sure that it lasts from start to finish and the quality doesn't drop at all.
Bradley's checking out an unusual acquisition in this shipment, sea blight, an exotic garnish that grows wild among ocean dunes.
Quite sour and a native ingredient, so a fantastic addition to the menus.
After a working day that began 13 hours ago, it's lights out for train manager Deb Munn. Though I hear she sleeps with her radios turned on.
Off we go. Just cheering. Grab my bag.
I'm stoked for tomorrow and our first glimpse of the outback. The Ghan travels 800 kilometers through the night to reach the outback.
So it's our first morning here. It's about 6 a.m. and we're in Marla, population only 70. The Ghan is right behind us, and they've stopped the train here to let all the passengers off to watch the sunrise. They've set up these tables and they're gonna have breakfast for everyone. And when the sun does come up pretty shortly, it's gonna be our first real look at the outback, because we got into the outback proper in the middle of the night last night. Where are you from?
Italy.
You're from Italy? Oh, wow. Did you always wanted to ride this train?
I was stationed for something special for our honeymoon.
This is your honeymoon?
Yes.
Oh, congratulations. An Italian honeymoon in the outback.
Yeah.
This train is awesome.
The night manager has an interesting strategy to keep us near the train.
Do you let people kind of go further on?
No, look, that's why I'm sort of standing here, because, you know, we've got some of the most deadliest snakes in the world just out there.
Out there?
Yeah, and so we're just trying to make sure that people don't get attacked or bitten or whatever. I don't want to have to be flying in a flying doctor or whatever.
That's bad for business.
Yeah, exactly.
His strategy works. Everyone sticks close to the train. The famous red desert sand stretches on forever. Just stunning. But you never know what's waiting out here in this untamed wilderness. The mighty Ghan charges cross-country through the giant red center of Australia. Rough, raw, and remote.
G'day, Mike. Scotty on NR75 on the Ghan. How are you, mate? All right, Scotty. Yeah, okie dokie, pal. Very good. Thanks, mate.
You get a whole new perspective up front with drivers Scotty Fells and Mick Kavanagh.
Still probably one of the best logos about.
They ride through some of the worst possible conditions on Earth for a train. Extreme temperatures in the middle of nowhere.
I can tell you, when the air conditioner fails, it's 50 plus degrees in here and it's not particularly pleasant.
We travel hundreds of kilometers without seeing a soul. Any kind of breakdown out here can be pretty scary. That's why the UGL Maintenance Workshop runs 24/7, 363 days of the year. Because the Ghan locomotives can't risk any equipment failures en route.
This is an air conditioner unit for an NR class locomotive. We change these out when they fail on track due to extreme conditions. When the unit fails, I could just imagine what the temperature inside the cab's going to be.
This air conditioner is only 2 years old, but in the outback, it will wear out before its time. So they hoist the unit out. And technician Joel Parker installs a brand new replacement.
Hey Ray, can you stick your head in there and make sure I crush the cables, please?
All right, you're clear to come down, Joel. Looks good.
Next, Aaron opens the massive engine. He shines his light on the cam, the crank, and the pistons, searching for signs of wear.
You're also checking for water leaks. We have internal water leaks, which can cause a compression lockup. And when that happens, we bend rods. When we bend rods, we do engine damage and the locomotive won't run.
He pays extra special attention to all the bolts.
One of these main bolts, if they're loose, then the main rod separates from the crank, and then we've got total engine failure.
Today's a good day. Everything's where it should be. Back on the Ghan, we're just pulling into Alice Springs, in the dead center of Australia. It doesn't rain often in this desert town, so today's winter drizzle has put Deb, the train boss, in a bit of a rut.
What happened here is we use this device to lift our guests that are immobile off the train, and because of the rain, we've got it bogged in just a tiny patch of dirt. So this is how we've had to figure out how to get it out of the dirt.
Deb isn't shy about getting her hands dirty, as she and the station manager talk a forklift operator through the rescue effort.
Just lift it from here, come on this side, okay.
After 10 minutes of maneuvering, the lift is up and running.
Do you know which coach you're heading on today? Right there. Yeah?
Now Deb can get all the passengers off for their tours of the outback.
Do you know which coach you're going on?
About half a kilometer down the train, the lounge staff restock beverages while the train's water supply is topped up. And the motor carrier gets a once-over to make sure the vehicles haven't worked loose over the past 1,500 kilometers of travel. I've been looking forward to this stop for days, because now I get to ride into another part of Ghan history. Aboard a very special guide, Pixie.
Just like that.
It's great.
She likes eating too.
I think we're related. Her owner, Marcus, runs a camel farm just outside Alice.
It's quite funny, you know, like the camel is actually assisted in doing all the railway line. You know, they're bringing supplies up for all the workers and stuff.
Camels opened up the outback the way horses transformed North America's Wild West. In the 1860s, thousands of these hardy beasts were brought in from all over South Asia to haul the people and cargo that built the Ghan. The camel drivers came from countries across the Middle East and Asia. Locals lumped them all together as Afghans. That's how the Ghan got its name, short for the Afghan Express.
You know, I admire those old Afghans. I mean, I've got photos old historical photos on my walls of the old Afghans, and they're my heroes.
They were tough.
Yeah, tough. And the knowledge that those men had about these animals, I would never be able to learn that stuff.
A lot of that knowledge was lost to history once the railroad was built and the camel's job was done.
And then once the railway was established, they lost their jobs.
So they played a part in their own being obsolete.
Yeah.
Time to leave Alice Springs on our Iron Camel. It's raining hard. The modern Ghan is built to handle a lot, but this kind of downpour can be the Ghan's worst enemy. The Ghan leaves Alice Springs in the middle of a soaker. Sudden heavy rain does happen at this time of year. The crew is well aware that this is a real safety challenge.
Water and electricity doesn't mix, especially when you've got 3,000 kilowatts of power running through the locomotive.
That's why maintenance teams do a special test to make sure the compartments of electrical systems are completely waterproof. About 2,000 liters of water are blasted at the cabin. Aaron is looking for any signs of cracks in the shell or joints of the locomotive.
We checked it out and it looks fairly good. No signs of any obvious leaks.
It's my second night on board the Ghan.
Good evening all, how are we? How are you?
I've been invited to join the guests in the exclusive Platinum Dining Room for a little taste of exotic Australian foods.
I've never had crocodile. Should I try the crocodile?
I think you should, it's Australian.
I'll do the crocodile as the entree, and I will try the barramundi.
Barramundi is a fish that's native to the rivers of Australia's Northern Territory.
Seal the skin side down first to get it nice and crispy, and then we flip it at the end.
Have I tried it? Yeah, I have. It's quite nice, yeah.
In a way, the Ghan is Australia. I feel like I'm getting more than just a taste of this country.
That's all right, and 2 duck salads.
Thank you. Perfect. Thank you very much.
That's all right, enjoy.
Thank you. This has always been an iconic rail trip. I mean, it is one of the famous trips of the world, and it's got some significant history behind it. What about the early explorers that did this on camels and walked most of it? To travel like this is just incredible, isn't it?
Well, cheers to the Ghan.
Oh, look, good on you.
By dawn, we've left the outback behind.
It's my second morning waking up on the Ghan, and the landscape has changed a lot from yesterday, too. We're getting a lot more trees and greenery right up against the train. You can certainly feel that we're starting to get into that tropical environment. And I'm also really starting to gain an appreciation for the size and scale of this country.
Our route now takes us way north of Alice Springs. We're on our way to our next stop at Catherine in the Northern Territory. Scotty Fells is taking over control of the Ghan locomotive. There are always 2 drivers on this train, and they keep a sharp eye out for the animals.
Just using your wits a little bit. Just little things about trying to preempt, I suppose, how an animal's going to react so you don't have an incident with them.
If he does spot wildlife up ahead, Scotty will apply light pressure to the brakes because it takes nearly 2 kilometers to come to a full stop.
Just so that the passengers aren't going to get a jolt if we do hit something, so the train's already starting to slow down.
Any kind of collision can damage the vulnerable air brake pipes at the very front of the train.
That's probably our biggest concern.
Drivers try hard to avoid hitting any wildlife, but they worry most about collisions with wild camels, descendants of Australia's original working herds. These big animals can really wreck a locomotive. Whenever the Ghan has an unfortunate encounter with a camel, it ends up back at the Melbourne maintenance facility.
They always get collision damage from animal hits and large camels and cows and stuff. So just changing the hose.
The air brake system uses pressurized air to control the brakes along the train. If the front hoses are damaged in a collision, the brakes automatically engage for safety, stopping the train.
There was one time when one of these locomotives hit 3 camels and caused significant damage to the front of the locomotive. Not the best job. When they come in, the hoses are either split, torn, and I just found that this one here's got a little hole in it. Even the brake pipe tap can be completely missing. All these hoses on the front can be totally missing.
Back on the Ghan, we're heading toward the northern edge of Australia. We're into the final day of our journey, and we've traveled about 2,700 kilometers from Adelaide, where we started. We're now officially in the Northern Territory. Next stop, the town of Katherine.
Oh, what a beautiful morning in Katherine.
Time for one last adventure in the wild heart of Australia. At one of the most important natural heritage sites in the whole country. We've stopped at the town of Katherine for an excursion into some very ancient history. This amazing piece of geology is 1.4 billion years old. Seeing it up close is a big reason why many passengers journey on the Ghan.
So right now we're on the Katherine River. We're in Nitmiluk National Park. We're going through the Katherine Gorge, or as it's now known by its indigenous name, the Nitmiluk Gorge. And it's a series of many different gorges that make up this incredible, very, very famous site.
There are 12 kilometers of 13 interconnected gorges, with walls climbing more than 70 meters high. They've been carved out over time by monsoon rains. This landscape is incredibly important to Indigenous people. Their ancestors first lived here an estimated 45,000 years ago.
Do you hope we see a crocodile?
Oh yeah, for sure.
Me too.
This area is home to the freshwater crocodile. Once in a while, there are sightings of its larger, nastier cousin, the saltwater crocodile, that sometimes makes its way upriver in wet season. This is Crocodile Dundee country. Wait, that looks like his hat. Actually, it escaped from one of my travel mates.
I'm like 1.5 meters away.
The Ghan is about to roll out of Katherine on the last leg of its journey. It's really heating up. The temperature is 32 degrees Celsius outside. And now we're heading into the even more humid conditions of the tropical north, and our final stop in Darwin.
10 minutes to the Elizabeth River there, Deb, over.
Riding the Ghan has been the trip of a lifetime for me and my new mates.
What will you tell people when you get back?
Just tell everybody to go. If you haven't done the train trip from Adelaide to Darwin, you've missed out on a hell of a lot.
Meeting lots of other people from all over Australia.
And you get to see the wonderful countryside. That's really special. Sharing in people's holidays, something that they've dreamed about, so you're part of their dreams. It makes it all worthwhile. You know you've done a good job. I'm receiving. Go ahead, over.
Deb Munn brings the train to its final stop in Darwin.
Hey Thank you so much.
You're welcome, Teddy. Have a great time in Darwin.
Thank you. It was a great ride.
Excellent.
Here we are in Darwin, the tropical capital of the Northern Territory. And what an incredible journey. Just thinking about how we started 3,000 kilometers away, Adelaide in the south, and now we're at the end of our journey, but also the end of the country. We're right at the northern tip. It's amazing to think what it took to build this railroad, and now I understand why people come from all over the world to take it.